Jim Al-Khalili, welcome to the show.
Pleasure to be here.
Once upon a time, when doing a lecture at the Royal Institution, you spoke about the famous double slit experiment, this strange quantum phenomenon whereby something sort of light appears to act as a wave and a particle at the same time.
Yeah.
And you issued a challenge. You said, now, if anybody thinks that they can offer a commonsensical explanation for this kind of thing, then do send me an email. How did that work out for you?
I wish I hadn't done that. I'd forgotten that I wasn't just talking to the 300 or 400 people in the audience at the Royal Institution, but obviously it gets recorded and goes out on their YouTube channel. To this day, I mean, that's about 10 years ago now. To this day, I receive on average 1 or 2 emails a week from people saying, I've solved the two slits mystery, where's my Nobel Prize? Oh, no, we've tried that. There's a lot that's strange about quantum mechanics.
Right.
Maybe we'll get into a few more of those things later on. But the great American physicist Richard Feynman said that the two slit experiment sort of encompasses the central mystery of quantum mechanics, that we know that when you send light through two slits and you get interference patterns, light and dark fringes. What's weird is that sending particles, indeed even entire atoms through, you get the same wave-like behavior when you send particles through. So I went through in this lecture, how come, we understand quantum mechanics is this wonderful, powerful theory that has revolutionized the world, helped our understanding of the subatomic world, and yet at its heart there's this counterintuitive idea manifesting in this two-slit experiment that we still can't explain properly.
So quantum mechanics is stereotypically thought of as the sort of weird, spooky, kind of creepy, leaves room for new ages to get in and say there's all kinds of, this could explain telepathy and this and that. There was certainly a time when we start discovering these strange quantum phenomena and we think, this is completely inexplicable. It still has that reputation today, but it's been, 100 years. Is it still legitimate to say, as Richard Feynman also famously said, anyone who thinks they understand quantum mechanics doesn't understand quantum mechanics? Is it still true to say that it is just weird and creepy and spooky?
Not all physicists and indeed chemists who also use quantum mechanics would agree on this. I would say yes, it is as mysterious as it's ever been. The fact is, it's also been such a powerful mathematical theory. It's helped us invent all sorts of things, understanding semiconductors, developing microchips and computers and smartphones and lasers and so on. It works, and it tells us how the atomic and subatomic world behaves, but at its heart it is still mysterious, and we do not yet have an agreed upon explanation of how. It's the only theory in all of science that seems to have got away with not requiring a narrative, an interpretation to explain the mathematical formalism. We have half a dozen or more different ways of explaining it, and you might say, well, so what? Because it hasn't stopped us doing the science, hasn't stopped us understanding the world. But at its heart, physicists and philosophers, I think, should still be worrying about this.
Yeah. Well, people often talk about interpretations of quantum mechanics, the Copenhagen interpretation, the many worlds interpretation, whatever. You don't hear people talk about different interpretations of gravitational theory in the same way. Why not? What's going on with that?
Because we do have a single interpretation. I mean, when we think about Einstein developing relativity theory, his special theory in 1905, the mathematics for that was pretty much sorted out. People, like Lorentz and Poincaré had already developed the equations. What they didn't have was the correct interpretation. What is this telling us about reality? Einstein comes along. He doesn't come up with new mathematics. He comes up with the correct interpretation, the narrative, the explanation of what this theory is telling us about the world. That nothing can go faster than light, that time and space must be unified into 4D space-time. So and Einstein's then credited with relativity theory. It's the interpretation, the explanation that's important. No other theory is like quantum mechanics, where the maths works, It describes the subatomic world, tells us about how atoms fit together and electrons orbit around the atomic nucleus and so on. But we have these half a dozen or more different ways of explaining what's going on, and we can't agree on which one's right.
Yeah. Well, it's the difference between like a mathematical model that like predicts outcomes, and I hesitate to use the word explains, but, you know, let's say describes the various activities of subatomic particles. That is a separate question from the ontology. What is the stuff? Like, people will commonly think about, you know, particles being in two places at once and being here and there at the same time, and that's probably some kind of confusion between our mathematical models, which sort of act as though, you know, a particle is in two places at once. Whether it actually is or not is a totally different question, and I think you and I probably both agree that it's not actually in two places at once, but it's like our mathematics describes it as such because it's useful. So does the quantum physicist of the modern era have much at all to say scientifically beyond their like philosophical hunches and interpretation of the data? Do they have anything like scientific to say about what is actually going on?
More so now than a generation or two or three ago.
Sure.
I mean, certainly when I started as a PhD student in the 80s, it was very much the case that, look, quantum mechanics is a mathematical theory. It works. If you want to do philosophy, go and do philosophy. But a physicist uses it. So this is the Copenhagen view. Sometimes it's simplified into the shut up and calculate interpretation. It works. Don't worry your pretty little head about how and why. We can't say, Copenhagen view says we can't say anything more about the quantum world beyond what we can measure and observe. What's going on behind the curtain before we look, we have nothing to say about it. Not that it doesn't so much exist, but we have nothing to say about it.
Yes.
I was always uncomfortable about that. And I felt somehow, you know, not that I was out on a limb, but it wasn't the prevailing attitude to worry. I think, well, something must be going on. You mentioned, you know, the ontology, you know, but there is something, some objective reality out there. That wasn't even regarded as you know, cut and dried. You know, the quantum mechanics just tells us what the results, making predictions about the results of measurements. Most physicists today, I would say, maybe not my generation, but younger than me, are a bit more concerned. There is something going on. I want to understand what it is. That should be the job of the physicist.
As John Bell famously said, the job of the physicist is to understand the world, contra Niels Bohr, who in one of your books you sort of blame for this functionalist view of science to some degree.
Which is a shame, because I mean, Niels Bohr's a great hero of mine.
Yeah.
But yeah, I mean, if Niels Bohr and John Bell, I'm siding with Bell.
Yeah, because they have this conversation, which I've been talking about so much recently, about what science actually does. And in fairness, I am more in line with the view that science is functional, that it only describes and doesn't really explain or tell us about the nature of what things are. But I'm definitely in your camp that whether you call it science or not, we should be interested in what stuff actually is. I mean, when I spoke to Sabine Hossenfelder, I was asking her about if I blew a trumpet, and I discovered that every time I blow this trumpet, a red light turns on over there. And I thought, that's interesting. And I figured out that if I blow it harder, if it's louder, the light is brighter, and if it's a different note, it's a different color. And I worked out exactly what was going on. And so I came up with this predictive machine, perfectly accurate. I can, if I play this note at this volume, the light will do this. And I got it right every single time. And somebody asked me, like, why does the light turn on? I said, oh, because I blew the trumpet. It's like, but why does it do that? And Sabine Hossenfelder sort of said to me, that's it. That's enough. That's what science does. And I'm like, how could you not go further?
I couldn't sleep at night if that's what science was about. You know, if all we cared about was, I remember someone telling me that they wore, you can wear these copper bands, bracelets that seem to have some medical curative power. And it's the same with a lot of alternative medicines. So, but it works. You know, we don't care if it's, what the mechanism is. The fact that it works is enough. For me, as a physicist, no, I want to understand how and why. If all you care about is applying some mathematical equation, that for me is, I don't know, that's engineering.
Yeah.
Right?
It
A
certainly feels like
physicist
it's
wants
missing
to
something.
understand how. How did the trumpet get to the light?
Exactly.
What is the interaction, the force between them that's causing that to
Yeah.
happen?
But to what degree do you think that science can answer that question fundamentally? Like what stuff actually is? Because the reason I ask is because, if I were to ask what a table is, you might tell me this table is made out of wood, and if I ask you what wood's made out of, and so on and so forth, we get down to an atom's made out of an electron. Well, what's an electron? And at this point, a lot of philosophers of science will say that the only answer is something like, well, an electron is a negatively charged particle. Well, what does that mean? Oh, it means it acts in this way. It repels other negative.
Yes.
But that's not what it is. That's what it does. And so at a fundamental level, especially in the quantum realm, where we're dealing with what are hopefully, or if they're not, hopefully we'll find at some point, atoms in the true sense of being atomic, like fundamental particles. And we're asking what those things are, not what they do, not how they behave or how they relate to each other, but what they are. Do you think that is a question for the physicist?
I think it is, and I think they should try. It may be that we're peeling back layers of the onion, but it's also true that there are different scales at which certain explanations are sufficient. I don't need to understand the workings of the standard model of particle physics to work out how a washing machine works. At the level of table, it's made of wood, and wood has this property. That may be enough for my explanatory satisfaction. But I can go deeper, and I can talk about it being made of atoms, and atoms being made of smaller particles. And it may well be that there's more to come. But I think had physicists said, no, it's enough to know that a table is made of wood, we wouldn't understand then the nature of atoms. We have tried to go deeper, and very often we have arrived at what objective reality is at a deeper scale. That may not be the end point. Of course, there may not be an end point. We may never reach it. We may not be able to. But there is a truth about the true nature of reality. There's another concern that people have about, well, all we are ever doing is perceiving the world, and so building models in our heads. That's epistemology rather than ontology. But there is a real world out there. And I think the job of physicists is to get as close as possible to that objective truth.
Yeah, I find it interesting. I've heard such a variety of views, not just on whether it's accessible to science, but what that fundamental stuff might be. I have Brian Greene telling me it might be vibrating strings. I have Philip Goff telling me it might be consciousness itself. I have theists telling me that it's being, and that all participates in God. And the one thing that I've realized is that the people who seem least confident in having a view on what the thing is, the ontology, tend to be the scientists I speak to, because they think that explanation consists in descriptions and models and mathematical predictions and stuff, like Sabina Hossenfelder did, or because they recognize that it's a question that's very difficult not to be a bit agnostic on, and it's like the philosophers who sort of have that kind of confidence. But at the very least, I agree with you that it should be a project for whoever you are, scientist or philosopher.
I think I would side more with that latter view, that there's a certain built-in agnosticism in the scientific method, that we should not be so confident and sure of our explanations because something may come along tomorrow and overturn those views. A good scientist is one who's prepared to change their minds. When it becomes an article of faith or belief, if you are so confident that string theory is the correct description of reality, then you're not doing science properly, because you need evidence. Physics is an empirical pursuit, and we need data, and we need to observe, and we need to be prepared to change our minds. So physicists acknowledge that there have been revolutions in science all the time, overturning previous ideas.
Yeah. So what is it about quantum mechanics that makes it so subject to different interpretations and difficulty and weirdness? Is that something intrinsic to quantum mechanics, or is that just because it's the newest thing that we're interacting with? Or is it actually about quantum mechanics itself?
It is. I think we've, after 100 years, but it's not taken us that long, but I mean, very soon we realize that it's something intrinsic to the description of the quantum. The way the quantum world behaves is and it's not just that it's far removed from our own everyday senses and experiences, it really is strange. And it's like the bump under a fitted carpet. You can move that bump around. You can shove it behind the sofa, behind the TV, so it doesn't show up. But that bump is somewhere. You can say that bump is many worlds branching out. You can say it's a non-local field a la de Broglie-Bohm mechanics. You can say the quantum wave function spontaneously collapses. There are lots of ways of explaining, but that weirdness is there. It's where you leave it, where you decide the weirdness originates, is what we can't agree on.
Yes. And so people will have ideas. There'll be people listening who are super familiar with quantum mechanics, and some who think to themselves, okay, I know about quantum mechanics. I've heard of the double slit experiment, something about particles and waves at the same time, two places at once, entanglement. But as we've already indicated, some people have misconceptions about what's like. So can you help us to dispel one or maybe a couple of important misconceptions about why quantum mechanics is weird, and then give us an indication of some of the things that actually do make it a bit weird?
Well, I mean, very often one of the most often asked questions I get when I give public lectures is quantum mechanics and consciousness. And this goes back to work of Roger Penrose and Hameroff talking about the nature of consciousness having some quantum origin. And most quantum physicists will say, look, quantum mechanics is mysterious. Consciousness is mysterious. That doesn't mean the two are connected. It may be that they're connected, but we're a long way from being able to see that. And people say, entanglement, quantum entanglement, this weird property that Einstein didn't like. He called it spooky action at a distance. Two separated particles can nevertheless be part of the same quantum state and therefore instantly in communication with each other. People say, that will explain telepathy. Or that'll explain why twins somehow can sense, when the other one something's happened to the other one, they can sense it because their brains are quantum entangled. The fact is, these strange quantum phenomena and mechanisms are very much confined almost always to that subatomic realm. They are ephemeral, delicate features that disappear very quickly. We now, in modern terms, we say the quantum effects decohere. The quantum weirdness, the being in two places at once business, dissipates like heat dissipating from a hot object when you put it in the freezer very quickly once you scale up. So when you scale up to our everyday world, the idea that you can invoke quantum mechanics to describe telekinesis or telepathy or the nature of consciousness or alternative medicines, it doesn't fit with the science. Just because quantum mechanics is weird doesn't mean we're allowed to invoke it to explain any other mysteries we don't understand.
Some people might say, for example, it's a little bit weird that some birds, for example, seem to be able to measure the whatever it is, the magnetic pole of the Earth and use it to navigate. And it's a little bit strange that they seem to have this ability to navigate just based on this magnetism of the Earth that we can't perceive. And as far as I understand, especially with some of your work in quantum biology, which is really exciting, one great theory for the way that they do that, it involves quantum entanglement in the eye, right? And so people might say, okay, let's not jump the gun. Let's not say anything without evidence. But doesn't this weirdness at the quantum level at least open the door to the possibility of a lot more weird kind of macro level stuff?
It does. And I think this is where our earlier conversation about wanting to understand how something happens, with the ideas that these birds and certain other mammals have this magnetoreception. First of all, that was discovered back in the 70s before anyone thought about a quantum origin for it. And even then it was poo-pooed, despite the research being published in one of the top journals in science. In fact, the journal called Science. People were arguing, how can the Earth's magnetic field is so weak? It's one thing sticking you in an MRI scanner and mapping the body, because those are huge magnetic fields. The Earth's magnetic field is so weak. How could it possibly have any effect on chemistry inside living organisms? And yet they found evidence that these birds really could sense the orientation of the Earth's magnetic field, not like a normal compass, but simply how far away from the North or South Pole they were. The lines of field, the iron filings, if you were to scatter around the Earth, assuming the Earth's a big magnet, whether they're parallel with the ground or vertical. Birds could sense that. And no one knew how that could happen. Where was this built-in compass inside these creatures? We know it works, but how? Quantum entanglement inside a protein called cryptochrome inside the bird's retina is far-fetched, but it's the only theory that we can actually explain step by step. There's a whole chain of, your trumpet to the light. There's a whole sequence of mechanisms in the real physical world that start off with this strange quantum mechanism entanglement that will explain how these birds get directional information. It may not be true, but here is an example. But you're looking at two electrons spinning in different directions within a molecule inside the retina. That's down at the quantum level. That doesn't mean you can scale up and say, well, quantum entanglement can explain telepathy, for example.
It is strange to think that there are these effects and truths and mechanisms that just disappear as you get bigger. And the question that raises for me is that, famously, the big trouble is that we've got this quantum mechanics over here, and we've got our macro classical physics over here, like Einstein's theory of relativity, and they don't want to go together. Maybe we might want to talk about why they don't go together, but most people know that they just don't somehow. And the goal is this theory of everything, or something that will at least unify those two explanations.
Yeah.
Is it possible that for some reason that we don't yet understand, things do just work differently at the quantum level, such that you will never have a quantum theory of gravity or some classical understanding of quantum mechanics? Because that sounds weird, but it also sounds really weird to me to say that there are all of these things like entanglement and tunneling and stuff that if you increase the size enough, they just vanish into thin air.
Yeah, there are two issues. One is, how do you move smoothly from the quantum world to our everyday classical world? And that doesn't require going on to Einstein's general relativity. Right. It's just simply where's the boundary between what is quantum, what is classical. And I think we're starting to understand that.
Okay.
That as you get more and more quantum systems accumulating, then they become more and more entangled, and it's more and more difficult to keep hold of the delicate quantum effects. It gets washed out. You get what's called decoherence. The early pioneers of quantum mechanics, Niels Bohr, Heisenberg, people like that, talked about there being a sort of a cut, a sort of hard boundary between the quantum world and our classical Newtonian world. And they said, how do you get something from the quantum realm, the entanglement, the two places at once business, to our sensible results? We never see two people in the same, one person in the same two places. And they called it some irreversible act of amplification, which is just vague. Now we're starting to understand it's to do with increasing entanglement, increasing decoherence, where the quantum weirdness leaks away, and as a physical mechanism, as something we can understand. What we don't yet know is how to unify quantum mechanics with the more accurate picture of the large-scale reality, which is Einstein's general theory of relativity, Einstein's theory of gravity. And there, it doesn't work simply because the mathematics, the theories are very different. They just don't mesh together. It's an interesting point that you mentioned, that maybe they don't. Maybe each to their own domain, and we have to live with that. But there are situations where you would want both to explain what's going on. For example, the singularity at the center of a black hole.
Sure.
Or the Big Bang. Or even, if you think about it, imagine a single electron in a superposition, a quantum superposition of being in two places at once. Essentially, you're saying it's not the electron is doubled up. It's one electron, but its quantum state is spread out. Well, an electron has mass, And we know from general relativity that mass causes space-time to bend.
Yeah.
Ever so slightly for the case of an electron, because it's a very tiny
Yeah.
mass. Nevertheless, that would mean that space-time is in a superposition of bending in two different places.
Wow, yeah.
Now, if we want to talk about space-time, we need general relativity, curvature of space-time, general relativity,
Yeah.
and yet the superposition thing is quantum mechanics. So there's an example, even though it's be far too tiny to actually check experimentally, nevertheless, theoretically, in principle, you need both theories to explain it.
That's interesting.
And so you can't just say, well, we'll never have to worry about general relativity. Maybe in practice we never will, but in principle, we should always need some combined theory.
I'd never considered the effect of the mass of quantum particles.
I read it. I read it somewhere.
On
Someone else very clever pointed this out.
Cool to think about.
Good example. I'll use that.
But then, some people might say, like, well, there are all kinds of paradoxes of space which seem to indicate that maybe there is just a smallest possible distance, and maybe that's somehow related to space-time, and that, like, if you get small enough, or if you get to the smallest possible distance, it's also the smallest possible unit of space-time, and therefore it can't be, bent or shapen in any way because it's as small as it can get. At the very least, it's a bloody mystery, isn't it? I mean,
it is, and we have ideas, and people can spend their whole careers pursuing a particular way of explaining things, whether it's something like string theory or what goes on down at this so-called Planck scale. But the deeper you go, the harder it is to test your ideas. And ultimately, as I mentioned before, physics is an empirical science. We need data, observation, experimental evidence to tell us that our theory is on the right tracks. We don't know how to do that when we're probing reality at such a scale.
You've been doing a lot of work on time recently. And when we talk about this, one thing that comes to mind for me, as someone who's not a scientist, and so I don't know if this is relevant at all, but part of the problem with, like, quantum mechanics is, for example, these entangled particles seeming to be able to communicate instantly across space. The interesting thing about relativity for me is that it shows that time is not linear. Time travels at different rates depending on, like, mass bending space-time. But on the quantum level, to talk about this weirdness of, like, instantaneous information travel, does that kind of assume that there is a universal present? In other words, is the problem of time relevant to the inconsistency between relativity and quantum mechanics?
I believe yes. I think we're struggling to reconcile not just quantum mechanics with general relativity, but also with the other big idea in physics, thermodynamics.
Yeah.
And it's strange that each of those three big pillars of physics describes time in a different way. So quantum mechanics, like Newtonian mechanics, in fact, classical mechanics that we learn at school, regards time simply as a label, as a parameter. It's called coordinate time. So it's basically, here's an equation that describes how something changes. I can work out what its state is at a particular moment. Then if I change that t in the equation, t for time, to some other value, I can crank the handle and work out what that system's doing at that later time or at an earlier time. That's all time is. It's just a parameter that goes into an equation. General relativity says, no, time isn't just a number. Time is a dimension. It's part of the fabric of four-dimensional space-time. It's a real thing. In fact, it's, all times coexist. And then thermodynamics says, no, time isn't a dimension, it's not a number, it's an arrow. It's a direction pointing from past to future in the direction of increasing so-called entropy. So I think until we reconcile these very, very different pictures of physical time, we're not going to be able to reconcile those theories themselves together. I think time may not be the central thing that needs to be solved and to get it, but I think it's part of that question. Until we understand these disparate different ways of describing time, we're not going to come up with a theory of everything.
Yeah, I mean, time sort of looms over everything. You can always forget that it's there for some time when you're talking about atoms and how they interact and stuff, and suddenly you realize that all of that is happening, and the conversation that we're having is also happening through time. Aristotle famously said that when he's not asked to define it, he knows what time is. But the moment someone asks him to, like, explain it or say it or define it, he's like, I haven't the foggiest. I think it's quite boring when people bring physicists on podcasts and ask them things like, do aliens exist? Or, like, why is quantum mechanics so weird? And one of the questions that's along that line is like, what is time, man? But I think unavoidably, and I'm not necessarily asking for an overview of the philosophy of time, but for you, with the work that you've been doing, what do you think time is? How can we start talking about it?
Well, I start with, what a number of philosophers do, which is to divide it into two categories. There's physical time, which is the time that appears in quantum mechanics and relativity and thermodynamics. It's the objective, the time that's out there that we try to understand. And then there's what we call manifest time, our psychological time. And it's one of those subjects, we're embedded in time. It's so difficult to extract yourself from it and look at it and study it objectively. We can't help but being embedded in time. And it's the manifest time, psychological time, that gives us this notion that time flows, that there's a now that's real, and that the past has gone and the future has yet to exist. And it's, I think, one of the main problems is, how do you reconcile our psychological perception of time, this manifest time, with physical time? Physical time says there's no such thing as flow. That's just an illusion. But then some physicists and philosophers will go even further and say, look, the whole time itself is just an illusion. Some will even go as far as saying time is just something we invented to order events or to measure intervals between one event and another. I think I don't agree with that. I think time is real. I think it exists in the same way that space exists, but not in the way that Newton believed, which said that time was absolute. There's some cosmic clock ticking by the seconds, minutes, and years independently of us. Certainly within relativity theory, which probably is our best theory of time, space-time is real. It's a fabric of reality. Reconciling that with the idea that the equations of physics are time symmetric, and that the time comes in just as a parameter, or that time has a direction from past to future, that is still a problem in studying the nature of time, and it has been since Aristotle and before.
Yeah, and it's funny because you can say all of that, and I still feel like I'm left with this question. But what is it? Like, what is the thing that we're talking about? Like you say that there's this idea that we move through time. Okay, well, if time is a dimension like space is, well, I can kind of feel like I can move through space. I can move through space. I can see what that's like. I'm moving my hand, but I feel like I'm moving through time. But if I try to pay attention to what's it like? What's it like to wave my hand left and right? Well, I can feel it. I can move it. What's it like to move through time? Maybe because we can't turn it off. It's kind of impossible to know. So I'm not sure what like even mental image to have. Like when I think of space-time, for example, in the physical sense of like the three dimensions of space and being warped by objects of mass, I imagine most people do, like a bunch of lines running through space, like making all these cubes that grow and expand. And that's probably not accurate, right? But it's close enough that I can kind of think about things in that term. But when someone says time, and you picturing in your head like moving through time, literally, like what imagery are you thinking of? What kind of thing are we getting at here?
Yeah, I mean, typically in physics we talk about 4D space-time, or what we do is throw away one of the dimensions of space.
Yeah.
So we only have two dimensions of space and one of time. So then we have a 3D block. It's called the block universe.
Yeah, right.
That allows us then to maybe get a sense of what space-time, 4D space-time means. That's before you even start bending it, warping it due to gravity. But in that picture, you're right. You can look at space and say, well, I can get from one place to another. I can be over here. I can be over there. I can get over there. I can go back there again and at a different time. But you can't visit different times. And yet the block universe would say all times coexist just as all points in space coexist. So what is it about what we call now, that's the present moment, that seems to us, according to manifest time, to be drifting along, flowing along the time axis?
Yeah.
That is all we can do. And then even we think about in cosmology, we talk about, the universe entirely is described by general relativity, 4D space-time. So but the universe is expanding. Well, it's space that's expanding, not time. And the only way to get that picture is you start off with Einstein's equations and you manipulate them to get a new equation called the Friedmann equations, which has space stretching over time. And that's an equation like Newton's equations or equations of quantum mechanics. Their time appears as like a coordinate.
Yeah, right.
That shows it. So we have to revert to things changing over time in order to get any sense of them. What general relativity tells us about time is not something we can visualize, other than mathematically.
And so much about how we understand these things, I think, is down to how we visualize it. I mean, at one point, in somewhere, I'm sure it was you who wrote about this. I thought it was quite funny the way you said, well, one thing we know about time is that, time seems to move forward. And then you were like, or does it? Because you could say that if you imagine yourself as still, and time is like moving past you, then time actually moves backwards. And so you were sort of moving through it as it goes.
Yeah.
And I thought, oh God, yeah, okay, fair enough. I like both of those seem like completely equally legitimate ways of thinking about it. Time moves forward, time moves backwards. And I began to realize how much of what I understand about time is just based on the image I have.
We think about the river of time flowing from the past to the future. But actually, it's not. It's flowing from the future to the past. If you're on a boat moving along, drifting along in the river of time, you're looking backwards. You're looking at the past receding away from you into the distance. The future coming at you, you can't see. It's behind your back.
And that makes a lot more sense in terms of the fact that we can remember the past, but we can't remember the future, right?
See the past.
It makes more sense to look at it that way. You've talked about this block universe, which you can sort of imagine being God, like zooming out, seeing the universe, including the beginning of time and the end of time, all at once right in front of you. Philosophers have for a long time talked, and I think it's McTaggart who popularized these different ways of thinking about time. A, B, and C series, and most people are familiar with the first two, the A and B theories of time. So the A theory of time broadly suggesting that the present is what exists, the past does not exist, the future does not exist, and we are actually moving through time, and that's like a real thing, the commonsensical view of time. This B theory of time suggests that the past does exist and the future does exist, and you get this image of the block, and for some reason we are like conscious of just a part of it at one point. Something like that's going on. But you have these sort of two views of physics. It seems to me that general relativity, which seems to get rid of the ever-present present, the common present between everybody. Your time moves differently to my time and whatnot. That seems to me to point towards this block universe, because time is this thing which we can warp and move into and move out of in various ways. But having not looked into it much further than that thought, do you think that Einstein's views about time and interpretations about space-time necessarily lead to this B theory, block universe of time, or can we still salvage the A theory?
I think we can still salvage the A theory. I think the block universe idea, in which you're right, that there is no universal present moment. What is now for me is not now for someone else. And we know in relativity theory, in fact, I've taught this for years, something called the relativity of simultaneity, and the example is always two people in spaceships passing each other close to the speed of light, and they see two flashes of light, and one sees the two flashes, A before B, and the other sees the flash B before A. So which one happened first? Cause and effect, and so on. You can't violate causality. If something is causal, if A is the cause of B happening, then A must always happen before B for all observers. So I think this fuzziness in the now and the order of events around the now is very limited. I think the block universe can be a helpful tool, but to say that fuzziness about no universal now means all times coexist, I think it takes it too far. For me, Einstein's idea of a block universe and all times existing is a tool that is useful for us, but it doesn't reflect reality itself. I'm far more in favor of trying to find a way that physical time can map onto our manifest time, which is the one about only the present moment being real. I mean, it's interesting. We say that the past has happened; it's gone. It only ever exists in records that we access in the present moment. The actual past, it doesn't exist anymore. The future hasn't happened yet, doesn't exist. The present moment is simply the edge of the shadow between the past and the future. So in itself, it doesn't have any duration. So it also doesn't exist. Well, I've just done away with the whole of time then.
Yeah, that's right. And it also seems sort of paradoxical, because if you just say, it's easy to say, well, the past doesn't exist. But if the past doesn't exist, then okay, like, you know, Shakespeare doesn't exist, and neither does, I don't know, neither does Mac Miller, the rapper who died a few years ago.
Well, two excellent examples.
Yeah, but there are still things that we can say about them. We can say that one was after the other, and that still remains true. So it's not like it doesn't exist at all, or in any sense that we can't talk about.
But it exists in the present, in the sense that it exists as records in our memories, in books, in photographs, in films. Everything that has happened only continues to have an existence in every subsequent present moment, stored in records. But in reality, it doesn't any longer have a real existence.
Yeah. But it's weird, isn't it, that like most people will be aware of the fact that it takes a very small but measurable amount of time for any kind of sensory input, you know, the words you're speaking, the light that's bouncing off the objects in this room, to travel to my eyes or my ears and go into my brain and do their funny little calculations and stuff, to the extent that, like, I don't even know what it means to say that the present exists. Because if you were to sort of pause time, we're in a time slice, and you ask me what's the present, I would say whatever visuals I experience in that time slice and whatever noise is in my ear in that time slice. But those are actually products of
they happened. The
past.
Actual things happened before your conscious.
And even if you say, okay, but it's the vibration caused by the thing you're looking at, yeah, but even that has to be processed through the brain, and then I can't even imagine what it would be like in a time slice, because my brain wouldn't function if there were no time. And so I just don't know what it means to say the present, and I don't know what the difference is between now and now. Especially the difference between those two things now. I don't know what the difference between those two things is. Like, I have no idea what this thing is that we're going through. And so I suppose what I'm interested in is, as a physicist, is this kind of weird, almost philosophical problem of just being able to figure out what it is that we're dealing with a prerequisite of doing a physics of time? Or, like with quantum mechanics, can we kind of figure out ways to describe time and use it in our mathematical calculations, whilst shelving the weirdness of not really knowing what the present is and whether the past exists?
I think there are similarities. I think, you know, in the same way that, as you say, we can use quantum mechanics and go a very long way in describing a lot of physics and chemistry without worrying about whether there are parallel realities or not. Yes, we can do a lot in physics involving time and the properties of time without being able to answer questions about what is now. We can certainly talk about events taking place, and we can talk about intervals between events and how long that interval is. Maybe something that we don't know, different observers who are, for example, sensing different gravitational fields or moving very fast relative to each other, won't agree on. We can order events. We can talk about light cones and events having a future light cone, of all events that it could possibly have caused or influenced, and past light cone, all events that could have possibly influenced or caused it. We can go a long way in physics in using time to understand reality. I'm not as frustrated about not getting to the essence of what time is as I am about not getting to the essence of what the origin of quantum weirdness is. I want to be able to know, for someone to discover the correct interpretation of quantum mechanics, which I believe there should be. Because I'm a quantum realist, I believe there's an objective reality out there, and I therefore believe there's a correct way of describing how nature does things, regardless of our plethora of different interpretations. So I'd like to be able, before I die, to know what is actually going on in the quantum world. We may never get an answer, but I'd like to. In the same way, I'm not so worried. It doesn't keep me up at night thinking, what is time, what is now, and so on. Maybe because I'm sort of reconciling myself to the idea that we are so embedded within time that we're never going to be able to understand it. Although it's a challenge that we should take on and continue to work on.
Yeah. How much time do we have for time?
There we go.
That's the question. You used a phrase earlier, which is used all the time. There it is again. The so-called arrow
Yes.
of time, which, as far as I'm aware, refers to the fact that time seems to have a direction. But beyond that, like, what is this arrow of time? Why is it mysterious? Where does it crop up as a concept?
It crops up in thermodynamics, developed, and statistical mechanics developed by people like Maxwell and Boltzmann in the 19th century and others, where they show that things happen a certain direction in time in a way that they don't happen in the opposite direction.
Yeah.
And it's normally associated with the increase in disorder, what we call entropy. You take a pack of cards that's unshuffled and you shuffle it and it will become more mixed up. It won't unshuffle itself over time. So it's statistical inevitability that things move in a certain direction. Boltzmann talks about having molecules of gas in a box, all sort of congregating in one corner of the box. Over time, they will spread out.
Well, if you spray an aerosol can, you have molecules just by the aerosol can, and if you give it some time,
they spread
across the room.
But what you don't see is these molecules spread across the room, coming back and then finding their way into the nozzle of the aerosol
or
can.
Randomly coalescing under that lamp over there.
And the basic idea there is that because it's highly improbable, it's not that that's impossible.
Yeah,
it's just highly, highly improbable that will happen. So there's a directionality. We can also think about it in terms of not just moving from order to disorder, but from moving from a system being away from equilibrium, moving towards equilibrium, towards thermodynamic equilibrium. When everything is, batteries run out, we get older, balls roll down hills, and so on and so on. That all has a directionality. The problem is that all our fundamental laws of physics, our equations of physics that describe how things change, are all symmetric in time. You can crank the handle one way and starting from a particular moment, you can say, what happens if I evolve this system according to this equation into the future? It'll arrive at the system will be in a different state. What if I crank the handle backwards and run it an equal length of time into the past? It will also evolve to the identical state that it would evolve to into the future. So time is symmetric in both directions. So the big mystery is, where does this irreversibility of time come about that we see all around us? The way we get around it is to say that, well, you have to start with the system in a special state that's off equilibrium, an unshuffled pack of cards, molecules in the corner of a room, and if you move forward in time, entropy increases. Yeah, but what about when you move backwards in time? Also increases. Well, what if that special moment we shove it all the way back and stick it at the Big Bang? That's the first moment in time. Now all we have is forward motions. We only ever see entropy increasing. There was no time before the Big Bang, and according to standard theories of cosmology, and therefore you don't have to worry about the time symmetry. So this is what's called the past hypothesis, and a lot of cosmologists are perfectly happy with that. For them, that has solved the problem of getting irreversibility from time symmetric laws of physics.
A few questions come to mind for me, right? And it's all got to do with the fact that the laws of thermodynamics in this degree are, as you said, probabilistic. That is, I mean, you can imagine if I sprayed this aerosol can, you can imagine, say there were just 100 molecules that come out of the aerosol can, and they are all randomly vibrating in different directions. They bump into each other sometimes, they're randomly vibrating. Just because there are 100 of them, if you give it enough time, even though it's all random, they will, on average, just spread out and go off in their different directions. In principle, they could all, very low chance, they could all happen to vibrate in the same direction, and all of them just go one way as a group. It's incredibly unlikely. Could happen in principle. Same thing in the real with the actual number of molecules there are. Like, they spread across the room because they're all vibrating and flittering around. But in principle, it would be possible for them all to go one way rather than the other. So this law, quote unquote, that entropy always increases, is actually just a really, really strong probabilistic prediction, right?
Yeah.
So I suppose one question that comes to mind is, if this is what we're using to get rid of the problem that our physical laws work one way and work the other, If I were to actually understand the position of all of those molecules and the way in which they were vibrating in principle, and I described, their trajectory coming out of the aerosol can into the room, can I not also just reverse that? Once I'm actually certain of exactly how everything's vibrating and I get rid of the random element, if I reverse that equation, wouldn't that also work in reverse? And therefore, the molecules would all shoot back up into the can, if you know what I'm getting at?
Yeah, I mean, so this is some people. So the physicist Carlo Rovelli talks about this. He refers to it as when you don't see all the details of the motions of the individual molecules, you have this blurred vision, this myopic view of this system, and so you can't tell apart all the different arrangements of the molecules of gas in a box when it's in thermal equilibrium. It all looks pretty much the same, but you can tell if all the molecules up in one corner. So that's a special state that you can distinguish from thermal equilibrium. Zooming in and knowing the direction of all the molecules, yes, any arrangement is as likely as any other.
Right.
It's just that there are a lot more ways of arranging the molecules of the aerosol spread out
as a high entropy.
There's more ways of arranging it, and you can work them all out, and one can move to and you can calculate. It's just as likely to go to this as to that. It's just as likely to go from a particular arrangement spread out to all of them congregating at the nozzle of the aerosol can as it is for them to all spread out in a different way.
Okay.
But all the different ways of spreading out, there are many, many, many of them. And we tend to congregate them all together and say those are all the indistinguishable microstates within that macrostate that we call thermal equilibrium.
Yeah.
So it's still, you don't get away from this idea that congregating at the nozzle is an unlikely special type of state.
Yeah, see, because it's satisfying to me that we have this one thing at least that works one way in time versus the other, but it's the one so-called law that is probabilistic, that isn't because I guess what I'm asking is if all physical laws are reversible, and you say, well, that's a problem, and the way we solve that is by referring to thermodynamics, which isn't actually a law. It's not actually if P then Q. It's this is probably going to happen. It seems to me if I reversed all of the in fact laws that were governing this entropic increase, I could in principle just reverse that too.
Well, I would argue that yes, it's probabilistic in the sense that entropy increasing in this probabilistic view, Boltzmann entropy, is what we'd call statistical inevitability. It's much more likely to. For me, it's a law that says it's much more likely to go in one direction than another. There is an arrow of time. The fact that there is a small possibility that points in the other direction, there's an imbalance.
Yes.
And for me, that imbalance is a directionality. It's not an absolute. It can never go back. Much more likely to go in this direction than that direction. That's where I'm pointing. I'm pointing in the direction of more likely.
Gotcha.
And that's the arrow. Now, I have something I talk about in my book. Doesn't come out till next year, but I spent ages trying to get my head around this. I would wonder whether this fundamental arrow of time is somehow baked into the universe. That there is a directionality of time. And then you might ask, but how about all these fundamental underlying time symmetric equations of physics and laws of physics? Well, the thing is, they only ever apply to isolated systems, to systems that are not interacting with their surroundings. So for an isolated system, yes, everything is time symmetric. And sure, if it's away from equilibrium, it moves towards equilibrium, but equally you could run it time backwards and it'll move towards equilibrium as well.
Right.
But the time symmetry only applies to isolated systems. Our universe, everything in our universe, apart from the universe itself, is not an isolated system. It's an open system where entropy will always increase because systems are interacting with their surroundings. So it may be that directionality is built in at a fundamental level, which means that time itself must be built in at a fundamental level to reality. And this
Interesting.
so it's not how do you get from time symmetric equations to irreversible arrows of time, but how do you get from an irreversible arrow of time to time symmetric equations? Well, you're isolated.
Isolation.
Stick a pendulum in a box in a vacuum, it'll carry on swinging forever, in principle. Yeah. And if you ran that video backwards, you wouldn't know that it was running backwards because it's time symmetric. Open it up to the air, and friction will cause it to slow down and dampen down. Suddenly it's an open system. Suddenly there's directionality.
Yeah. So it's like a problem of restricted scope, I suppose.
Yeah.
Okay, that's interesting, and I think I can make some sense of that, and I am trying my best here. One other question that came to mind was that we've sort of spoken about two areas in which probability rears its ugly head. One is time. We talk about time, and we say that the defining quality of time for a physicist is thermodynamics, and thermodynamics is actually probabilistic. Another area where probability famously comes up all the time, and perhaps unavoidably, is in quantum mechanics. And both of those are dealing with like the activities of very small little things. Is there some connection to be drawn from the fact that quantum mechanics seems to have an inbuilt probability, at least in certain interpretations, like the Copenhagen interpretation, seems to have this probabilistic element, but that we can use to make sort of calculations, but is ultimately probabilistic. And that probability is baked into the only thing we can use to measure time as moving in one direction versus the other, even though, like, on a macroscopic level, we can treat it like a law. Yeah, the entropy always increases, even though we can always treat quantum mechanics on the macro level like a law, atoms act in this way. Is there some connection between the probabilistic nature of quantum mechanics and the probabilistic nature of entropy and time? Or is that just like two completely different, isolated, croppings up of probability?
I'm not sure. I mean, one of the things that I'm interested in looking at is the increase in entropy down at the quantum level. So when a quantum system interacts with its surrounding environment, it becomes increasingly entangled with its environment, and decoherence can set in if the environment has macroscopically distinguishable, we say, states that you can tell them apart. So there is a directionality that just comes from quantum mechanics. But I think the probabilistic nature of quantum mechanics itself, of the quantum wave function, is deeper. The Copenhagen view, by the way, interpretation doesn't have this built-in understanding of what probability is. That's simply what's called the Born postulate. Here's the Schrödinger equation, and here's how we explain what the wave function in quantum mechanics is, and this is how probabilities come about. So it's like a recipe that was put on top of the mathematics of quantum mechanics. The realist interpretations try very hard to understand where this probabilistic nature of quantum mechanics comes from. The one that many people like is the many worlds Everettian interpretation.
Yes.
But that, many physicists argue, is still struggling to understand where probabilities come from. If there's two events, if say a quantum particle can do two things, one with a likelihood of 99% and one with 1%. It can either go left with 99% probability and right with 1% probability. In the many world interpretation, universe branches out. And in one universe, we see it going along the path that had 99% probability. In the other universe, we see it going along the 1% probability branch. Yet both universes exist, one might argue, with equal likelihood. They're both definitely there. So where do the probabilities come in? And a number of physicists are working on this, and there are ways of trying, but it's still a struggle. In other views, like Bohmian mechanics, probability comes in simply because our inability to accurately enough measure the quantum properties of a system.
Right. It's like a practical
yes, it's
problem.
actually a practical problem of like in the butterfly effect, in chaos theory, that you can't know the details You need to know the details with infinite accuracy.
Yeah.
And so there's a built-in uncertainty that we can never get rid of, and that's how these probabilities come
But
in.
it is in fact a practical thing in the same way that, like, if I were to throw a tennis ball, practically, if I was trying to work out where it landed, I'd have to sort of give a rough estimate. And
Yes.
so, yeah, you could in principle work out exactly where it went, but practically you're not going to be able to do it. And when it comes
but if you want to know
mechanics,
what it's going to do next into the future, the further in the future you want to predict how the system will evolve, the more accurately you need to know its present state, the more decimal places.
Right.
At some point, it becomes impossible to predict.
Yeah. As in, when you talked about the 99% going left and 1% going right, I instantly thought, okay, many worlds. There are 99 worlds in which it goes left and one which it goes right. But that's not correct, is it?
No.
Because I just wanted to say that in case anybody else thought that. It's not that there are 99 realities in which it goes left and one in which it goes right. Like, it either goes left or right.
Or you might as well say, if that's the case, they might as well say 10 goes right and 990 goes left.
Yeah. It's like there are two options, right or left. And yet if there's a differential probability, the many worlds interpretation might be correct that there are two branching realities, but it hasn't accounted for why one is more likely than the other, or what that even means if both exist.
If both exist with equal certainty,
then
where do the probabilities go?
Man. Okay, one more question for you, which is this. Could time be an emergent property of the universe? And if so, what does that mean? What is an emergent property?
It's possible, yes. And I think a number of people working in the foundations of physics are starting to talk in that language. Emergence is a quite a complicated thing to describe. The simplest way of describing emergence is, well, for example, consciousness is an emergent property. You know, it emerges once the neuronal connections in the brain become complex enough, and the system become complex enough. A much simpler example.
Temperature be another example?
Temperature's a very good example. The temperature itself doesn't exist when you get down to the molecular level. It's just vibrations of atoms and molecules. Zoom out, and you got something called temperature. The wetness of water is another one.
Sure.
You'll never appreciate wetness of water however much you study a single molecule of H2O.
Yes.
You need trillions of them together for that property to emerge.
The sponginess of a cake, perhaps, you know.
Yeah.
None of the ingredients or the atoms themselves are spongy.
Exactly.
Put them together and zoom out and you get sponginess.
Exactly. So the idea is that time itself doesn't exist at a fundamental level.
Mm-hmm.
It's only when you zoom out that gradually it emerges. That it emerges from something more fundamental. What that something more fundamental is, I think, is still something that we haven't understood yet. I mean, a lot of physicists have tried. There's a famous equation called the Wheeler-DeWitt equation, which starts from sort of more fundamental equations in relativity, and it's an equation that doesn't have time at all in it. So it's a fundamental feature of reality. Time doesn't exist. So the fact that we perceive things changing in time must be an emergent property of the universe if the Wheeler-DeWitt equation is more fundamental.
Interesting.
I'm not sure. I'm not saying that I disagree with that. I'm yet to be convinced that time is emergent rather than fundamental.
One of the, I asked earlier if the relevance of time is important to the incompatibility between relativity and quantum mechanics, because I've heard it discussed in some contexts that, and like I said, I'm not a physicist, I might be wrong about this, but one of the problems might be the way that they both sort of deal with time. Quantum mechanics might require instantaneous, the present is real and it's the only thing that exists, whereas relativity has this time block, this time traveling. If time is emergent, maybe it's just that the quantum world acts at a small enough level that time hasn't emerged yet, and so it makes sense to say that time functions this way on the quantum level, but once you're talking about general relativity, you're big enough that you have this emergent quality of time, which is a property of space-time. And I sort of wondered if having time as an emergent property at some higher level of complexity of atoms might help us to solve part of the problem as to why the big doesn't mesh with the small.
Yeah, maybe. I mean, that would suggest that quantum mechanics is a deeper level of reality,
right?
Where time has a more fundamental, or there's some fundamental feature of the quantum world that isn't the time that we perceive, and that general relativity and how it sees time as part of 4D space-time is emergent from a deeper quantum level. It may be. I'm not sure. I mean, all the research into finding a theory of quantum gravity, a theory of everything, there's still the debate. Do we start from quantum mechanics, or more correctly, quantum field theory, and do we move towards general relativity, or do we, so that's what string theorists would say, or do we start from general relativity? The space time is fundamental, and we quantize it. That's what people working in loop quantum gravity.
Yes.
So do you start from this end and move towards that end, or that? Or do you start from both and meet in the middle? Or do you scrap them all together and come up with something new? I mean, that's where we really are at with finding a theory of everything, that we don't know what our starting point is, that we can say, well, let's start from here. We know this is a correct description of reality. Let's figure out how to get to the other end.
Yeah. Oh man, that's amazing. It's like, I feel like I'm sort of auditing physics, because everybody keeps hearing about this theory of everything. It's like, someone's told you they're going to build a grand palace or a new hotel or something, and you come in and you speak to the builder, and it's like, okay, how's it going? How are we getting on? And they're like, I hate to tell you this, we haven't even agreed on how to start yet.
We haven't done the foundations
We'll
yet.
get there eventually, I'm sure. And in part, that will be thanks to people like you and works like yours. Forthcoming, it will all be in the description, all the information about the upcoming book about time, and also some of the other works that we've already mentioned. Jim Al-Khalili, thanks so much for taking the time. It's been fun.
It has been fun. Thank you.
Joseph Foley, welcome back to the show.
Thank you very much for having me.
What is logic?
God, there's no foreplay today.
Never. Never with us.
I suppose, like many things in philosophy, it depends who you ask. So, as it's traditionally conceived, sort of going all the way back to Aristotle, logic is supposed to be the most general principles of reasoning, such that when you have a set of stuff you already know or you're already asserting, you can, through a series of indubitable steps, get to a further conclusion that follows without any doubt and without any possibility of being wrong from those things you initially know. So, classic example from Aristotelian logic is all men are mortal, Socrates is a man, therefore Socrates is mortal. And effectively, Aristotle's point here is that you can't even imagine that being false. There's no situation where all of the premises are true and the conclusion is false. So you are carried, in some sense, from the premises to the conclusion without any kind of possibility for error entering it. And that's kind of the classic Aristotelian picture. And amongst philosophers, this has remained, I would say, relatively orthodox, right up until maybe the end of the 20th century. And even now, it has really, really staunch defenders. So this idea that there is a one true logic, and that's the thing that philosophers are interested in when they talk about logic. A recent book was put out recently called The One True Logic, that was defending this idea by Owen Griffiths and Alexander Pazzo, I think his name is. I only remember Owen Griffiths because he supervised my undergrad dissertation, and he wrote it with this other guy who I'm sure is very, very clever, but I've never met him, so his name doesn't stick in my mind. But another alternative conception of logic to this kind of historical orthodoxy, but in the modern day, I would say it's become less orthodox, is in some sense logic as tools. So logic as tools for modeling, or logic as ways of making sense and specifying different areas of discourse. So under that conception, you might have slightly different logics for different areas of life. And you might have logics that are, you can have different formal systems and different logics for dealing with different situations and different topics. So I'm trying to think of a good example. So a logical pluralist might say, for instance, that say you have a certain set of logical rules, so a certain set of axioms and rules of inference that is just as good as another set of axioms and rules for inference. They're just dealing with different stuff. So, this is kind of an analogous position, which is similar enough and maybe familiar enough for audiences to kind of get an intuitive hook onto this, would be something like, moral relativism, right? Which is the idea that there are different moral systems, each of which are in some sense as good as one another. And that is determined by, in a more relativist case, your kind of moral community. In this case, maybe by the context of what you're doing.
So logic can sort of be variable as to what it is and what its goals are, depending on what it's being used as a tool to do.
Yes.
So it's not some true thing that exists and can be ascertained, but rather it's like this methodology. It's a tool we use to perform particular tasks in particular areas.
Yes, so that would be a kind of classic pluralist conception of logic, and different pluralists will cash this out in different ways. But that's kind of, as far as I can tell, the sort of mainstream pluralist view is to kind of, roughly speaking, logic as tool. And this is kind of an ongoing dispute in the philosophy of logic: is which of these conceptions is true? Is there a one true logic? And there's a lot of very technical arguments going back and forth. I know in this conversation we're going to avoid technical stuff generally because it's just very difficult to speak out loud without writing anything down in a way that either is true from the speaker's perspective and also makes any kind of sense to anyone listening.
If you want to say a really, really complicated series of symbols and numbers and esoteric notation, I'll just get Alex to put it on screen. Isn't that right, mate?
But a classic kind of argument that might go back and forth between logical monist and logical pluralist is the logical monist might say something like, well, you've got to have some kind of criterion or set of criteria for what logic is strong in different areas, and in some sense that presupposes some kind of reasoning system. So one monist argument is to say to logical pluralist, you are at least committed to some kind of pre-existing logic when you are choosing between these different logics. And logical pluralist tends to kind of respond by appealing to the fact that seemingly different logical rules treat different domains very, very well according to different rules. So that's kind of a kind of quick gloss of some of the different conceptions of what logic is. I think that's
logic can be thought of as like a set of rules, like rules of engagement for not just philosophy, but kind of for thinking. They're thought of as like a prerequisite for thought. In order to have a thought, there needs to be like some logical rule by which that thought like functions. But it's also, as well as being thought of as like methodological, like the rules governing thought, it's also thought of as like the foundation of thought, as like a thing that actually sort of exists. But I guess the thing that exists are constraints. I mean, in a way, logic could be thought of as a system of like constraining axioms.
Yes. So I think that there's, again, this kind of, I don't know, touches against the fact that we use the term logic in a kind of number of different ways. We kind of have a loose everyday sense of just something being logical as sort of a byword for sensible or good or cognitively.
Oh yeah, we should clarify
that does bear a passing resemblance to what philosophers mean by logic, especially pre-19th century philosophers. Quite often, because one of the most interesting developments over the history of logic is, very, very early on, you've got that Aristotelian picture, and developing alongside this Aristotelian picture, or slightly later, but effectively kind of taking up alongside Aristotelian logic is Stoic logic. People think about the Stoics in terms of their ethical system. That's kind of the thing that exists in public consciousness. But Stoics also were very keen logicians. And many of the kind of standard terminology that we have today around logic is inherited from the Stoics. So things like modus ponens, modus tollens, these are Stoic logical rules. And those of you with a kind of background in maybe more, if you've done like an introductory course in formal logic, you might recognize that the Aristotelian picture is very predicate based. It's very, all A, R, B, that sort of structure. Whereas this modus ponens picture exists more at the level of proposition.
Okay, so help us understand this. So modus ponens is a form of argument.
Yes, so modus ponens is if P then Q, P therefore Q. It's like, the kind of, it's such an obvious rule that we use it all the time and basically barely think about.
Premise one, if this, then that. Premise two, this. Conclusion, therefore.
Exactly,
that.
Yeah. So,
and that's called modus ponens. That's like that form of argument is known as modus ponens.
Yes, and if that argument schema is occurring at the level of propositions. That's kind of full sentences. If it's light
blue.
outside, then the sun has risen. It's light outside, therefore the sun has risen. It's like, regardless of whether you think that's a sound argument, it is at the very least a valid argument. And that's using modus ponens. And whereas the Aristotelian picture is more about predicates and terms, in Aristotle's terminology, belonging to predicates and things like that. And the interesting kind of historical tidbit is that these two systems don't get unified until 1879.
Really?
With the publication of Frege's Begriffsschrift.
Wait, so this predicate version of logic is more sort of like, all cats are black. You're sort of predicating things of objects. All cats are black. Like there is a cat, therefore there is a black cat. That kind of way of thinking.
That kind of thing, yeah. So Aristotle has 4 types of statements in his logic. He has all statements, so all X or Y. He has no statements, no X or Y. He has some statements, so some X or Y, and he has the kind of denial of some, so some are not one. And these have interesting logical relations and stuff like that. But again, you notice
all cats
this is all
black. Some cats are black. No cats are black.
Yes,
and
some cats aren't.
Some cats are not black.
And you can kind of chart out the inferences between different formulations of these sentences and stuff like that. But my broader point is that that's all occurring kind of in the sentence. These are charting relationships between terms and properties of terms
within sentences.
Yes, whereas the Stoic system,
the if P then Q.
Yeah, that's kind of taking
the
sentences or propositions already and linking them together.
Yep.
And for a long time, Stoic logic was just really neglected. Kind of Kant went so far as to say that logic never advanced a step after Aristotle, which is like not only disregarding all of the kind of medieval thinkers who are very interested in logic, like William of Ockham. Ockham's razor was also a medieval logician. But also kind of Kant simply does not care about this whole branch of Stoic logic. But in 1879, Gottlob Frege, who's a kind of German logician and philosopher and mathematician, manages to unify these all into an incredibly elegant technical system. And it's just kind of, it's a very beautiful bit of history in the sense you've got these 2 systems that emerge kind of 4th century BC. And then over 2,000 years later, they're kind of reconciled. They're kind of remarried. When intuitively, these feel like they should go together. It feels like this should be reasonably easy to reconcile, but it takes an awful lot of mathematical machinery to make that work, such that it's not until the 19th century that these 2 systems, both of which are obviously correct in some sense, can be reconciled. You have this kind of, it's very difficult to think of now, the idea of there being, 2 rival true logics in a sense that clearly should be able to meld, but they just nobody can quite figure out how.
It would be analogous to like the modern scientific problem of general relativity and quantum mechanics. Where we're like, they're both true, but like they just don't. And physicists are searching for some way to put them together.
And Frege, one of the reasons why he's gone down as kind of the father of modern logic is because he manages to stick these 2 things together. And the way he does that is kind of technical, and I kind of don't know if it would be worth talking it through particularly, but anyone that's interested in it could go and have a crack at the Begriffsschrift. It's
homework.
It's fascinating. But one of the developments in logic is that initially people like Aristotle and the Stoics are largely conceiving of logic as something to do with language. So codifying patterns of reasoning in language that are obviously true. And as we get more towards modern logic, if I use the term logic in a philosophy faculty today, it will immediately conjure up images of formal systems. So axioms, rules of inference, proof systems, model theory, that kind of thing is the world of modern logic. And in a lot of ways, over the course of the 19th century, you get this kind of increasing mathematization of logic. And then kind of into the 20th century, logic kind of is firmly philosophy, but also firmly maths, which is one of the reasons why it's so fascinating. You can't, if you have a passion for technicalia, then logic is very interesting. Also, if you have a passion for philosophy, it's very interesting. And the other thing that I think, I realize I'm kind of pitching logic now, and that's kind of my goal with this. Is, I really do think that logic is an eye-opening thing to learn, and I think that what makes it so brilliant is that it's eye-opening to learn, even if you only spend a couple of hours learning it. Really, if you're not interested in kind of the mathematical side of it, even just 5 hours spent at, cumulatively over the course of a year, say, at a desk looking at a logic textbook will fundamentally transform the way you see the world.
Well, what does it mean? I mean, okay, so people will listen and go, okay, logic is the process of deriving conclusions from premises, and I can do that. I can look at, even if something is not true, I can derive conclusions like, all cats are black, Tom is a cat, therefore Tom is black. I'm clever enough to recognize that conclusion follows from the premises, even if the premises aren't actually true. The conclusion follows from them. Yeah. So what do you mean, like, learn logic? What kind of thing would I be learning if I sit down and spend 5 hours at a textbook?
So you'd be learning how to put
Except
things in...
patience.
Well, yeah, that too. But you'd be learning how to put things in propositional form and also spot, going beyond kind of looking at individual arguments and being like, oh, I can tell that argument's pretty good and I can tell that argument's pretty bad. Learning the structural characteristics that make an argument good or bad.
What does it mean to put something in propositional form?
So it is effectively to take, say we have we're talking and I say, oh, well, man, like, I think that Socrates probably will be mortal because all men are mortal, right? Aren't they? If we had a kind of conversation like that, and that's sort of a toy example, but you'll find this in pretty much any philosophical discussion. People kind of talk in paragraphs, how we naturally speak.
Mm-hmm.
And to put something in propositional form is to take that paragraph and extract from it the argumentatively relevant parts and say, right, here is the stuff that they're assuming, and here is the conclusion that they're drawing, and here are the rules that they're invoking to draw it. And the reason I think this can be very helpful is because quite a lot of the time, I think just in everyday life, we are often mistaken about, I think, what the people we're talking to are arguing.
Yep.
And one of the things I think putting things in propositional form can do is you can then, you have a working model of what your interlocutor's argument is.
Yeah, it offers clarity. And
Yeah,
you can agree with your interlocutor. Before you agree on whether the argument works or not, like you can first agree that this basic, clear form with clear like premises and conclusions, you can at least agree, is that the argument we're having? And then you can have the argument.
Yes, I think that in kind of non-mathematical practice, this is one of the best uses for logic ever. Leibniz was so keen on this use of logic. He thought that one of the, this is before we kind of had modern symbolic logic. He thought one of the things that we need to do if we're going to have conversations about philosophy or anything really, is we need to have a language that to the greatest extent possible eliminates ambiguity. And if in theory, we could take a very, very complicated argument and put it in like, second order formal logic or something like that. And that would be about as clear as you could ever get with formalizing an argument. That would take a very long time. Putting something in propositional form is sort of one step along that journey. So yeah, there are still things that can remain unclarified if you put something in propositional form.
Because it's a series of propositions.
Exactly, yeah. But at the very least, you are one step closer to having clarity. And I think that if you don't have clarity on what arguments you're using and what problems you're tackling, it's just very hard to make any kind of progress whatsoever.
Yeah. And notice the way that you, like when you were just thinking about how to put that sentence together, you were like, well, I think that if you don't have that kind of clarity, then it's difficult to put arguments together. That's an if-then statement.
Yes. So
I think people who are good at communicating will be good at sort of instantaneously putting things into clear propositional form. So instead of saying like, man, like I just feel like if like God has to exist because if like the universe obviously had a beginning, right? And if the universe has a beginning, then like God has to exist because what caused the universe? You could translate that into premise 1. Everything which begins to exist has a cause. Premise 2, the universe began to exist. Conclusion, therefore the universe has a cause. And that's way clearer, and you can interrogate those premises versus that word salad I said a second ago. You get what I'm saying? But you'd have to be like, well, wait, so when you said, so are you saying this? Are you saying that? And it would be a big sort of old jumble.
Yes.
And putting it into propositional form is the first step towards, as you say, clarity.
Yes, and I think that one of the great things about putting things in propositional form is, as I say, I think basically anyone could learn how to do that with almost any argument, almost any philosophical argument in an afternoon. If that, really. I mean, you just kind of, after a while, it becomes almost second nature.
And it will instantaneously, I mean, it doesn't mean you have to start talking in terms of premise.
No, not at all.
But it means that instead of me saying like, oh, God exists because I think that like, the universe began and like, obviously God must be I don't need to put it into propositional form, but practicing propositional form will at least allow you to say something a bit more clearly. Like you might say like, well, I think that, the universe had a beginning, and I think if it had a beginning, that beginning was God. That's not a logical argument. That's not fully like propositionalized, but the practice of pulling out, as you say, the argumentatively relevant like statements, the atomic sentences that make up the argument, and just dealing with those as clearly as possible is a wonderful exercise.
Yes. And this lusting after clarity is really reflected in the types of works that logicians have tended to write outside of logic. So again, to take the example of Frege is not only concerned with the idea of creating this perfect logical language, and he also wants to ground arithmetic in self-evident logical axioms, which he doesn't end up doing because of Russell's paradox, and then because of Gödel's incompleteness theorem later, which showed that he wouldn't be able to do it anyway. But alongside these aims, he is incredibly obsessed with clarity in language. A really good example of one of the methods that Frege uses to clear up ambiguity in language is he introduces the notion of a sense. So we think about a word and its reference, right? So I have a word, Alex. It picks out you. When I say Alex, I'm picking out you in the world. Frege notes that if this is our only picture of language, then we're going to run into some logical confusions. And these are, very, very rarely. For 99% of your experience, this isn't going to matter, but occasionally it really will. So I think the classic example of this is Hesperus and Phosphorus are two names for Venus in the ancient world. But people didn't realize they were the same planet. So Frege basically goes, well, they weren't obviously the same to the people. They had to then go out and verify that they were both, and they both happen to be Venus. So they Hesperus equals Phosphorus is a statement that is true out in the world. But Frege essentially says, well, they must have had a mode of identification for picking out Hesperus or Phosphorus, and that's what he calls the sense. And that's a very abstract example. It's not immediately clear how it might be helpful. But let's take, for example, you're just talking to someone actually about Descartes and Descartes' arguments about the separation of mind and body.
Yeah.
So, to go back over it, Descartes' argument about the mind being separate from the body is that he can conceive of the mind existing and the body not existing. So he says they must at the very least not be equivalent. These are conceptually separate entities. And you could talk about could reiterate that argument today with the nervous system. The mind must be separate from the nervous system because of this conceptual freedom that I've got to imagine the mind separate from the nervous system. And one way that people immediately think that there's something quite fishy about that argument. Like what's going on there? This seems like it's in some way tricking yourself in drawing a substantive conclusion from mere facts about language. And Frege's senses can come in real handy here because he can say they might pick out the same object, but your modes of identification, your senses for these two words are different.
As in you're saying the same thing, but in a different sense.
Yeah, exactly. And he has a very metaphysical picture of what these senses are. He kind of thinks they're in this kind of Platonic realm. But again, we don't need to get into that.
So a moment ago you said it was Phosphorus and Hesperus?
Hesperus, yeah.
Hesperus, which you told me earlier is, can't remember which way around it is, but one means the morning star, one means the evening star. And so people would look in the morning and say, that's the morning star. People would look in the evening and say, that's the evening star. Turns out it's actually the same star. So they are talking about the same thing, but they're not talking about the same thing because one person thinks it's the evening star, one person thinks it's the morning star, and unbeknownst to them, it's the same star. So I guess the paradoxical question is, are they talking about the same thing or not? And so Frege is saying, yeah, but no. They're talking about the same thing, but in a different sense.
Essentially. And it's, as I say, in a situation like Hesperus and Phosphorus, it's kind of quite intuitive that there's something like that going on. I think that the utility in something like Frege's sense and reference distinction comes in these more philosophical arguments whereby somebody's making a point about conceptual distinctness and maybe they're right and maybe they're wrong, but it seems like they're inferring too much from the linguistic facts at play. I tell you, a really good, you've talked about metaethics a lot on the channel before, and a key argument in metaethics is the open question argument, right?
Yeah.
Of any given definition or any given naturalistic definition of goodness, somebody can ask, is that really good? And we don't ask that for questions like, for identity statements like a triangle has three sides. If you were to say, does a triangle really have three sides? What does that mean? Of course it does. It doesn't have traction.
It's sort of like, if you've got a definition of an object, for that definition to be complete and full, you wouldn't be left with the question, but is that really the defined thing? So if you say, a triangle is a three-sided object with straight lines, and you go, yeah, but there's three-sided objects with straight lines. Is it really a triangle? Well, yeah, of course it is. Whereas it seems for G.E. Moore, who comes up with this argument that any definition you give of the word good, well, good is, pleasure. yeah, but is pleasure really good? It seems like that's still a legitimate question, which means we haven't got a sufficient definition.
Yes.
Well, good is what God commands. Is what God commands like really good? Are you sure? And you don't look with confusion and go like, what the hell are you talking about? It's definitional. It seems like, as Moore puts it, an open question, which Moore uses as an argument to say that therefore there can be no naturalistic definition of what good is, because whenever we define good, we're always left with this open question, but is it really good? Which we're not when we do have sufficient definitions like that of a triangle.
And say you wanted to solve this argument. Well, one of the things you might appeal to is senses. You might say, well, there is still a gap there to find a substantive definition of goodness that isn't just intuitionistic and kind of in this kind of Moore style irreducibility of the good. You would have to posit that the good and this other property are in fact referring to the same thing, but they're getting at that thing through different senses. And this is one way that people have attempted to solve the open question argument. I wouldn't be able to kind of rattle it off the top of my head. But for example, say, to construct an argument like that, a utilitarian trying to solve the open question argument might draw on this kind of Phrygian backdrop to say something like, well, yeah, no, I accept, right, that you can ask whether the greatest good for the greatest or the greatest net pleasure is good. I understand that when you're just presented with the words, you can ask, oh, is that really good? But say I went out into the world and I found that everything that elicited the good token also coincided extensionally, totally with the greatest net pleasure, then, or even like mostly, then a utilitarian could appeal to this Phrygian sense thing and say, well, maybe they're getting at the same thing. Maybe they're getting at the same reference through different senses.
Yeah.
So that, again, there's a couple of philosophical arguments.
An example that comes up in other contexts is the difference between water and H2O. Like they are the same thing, but they can kind of apply in different contexts. For example, somebody 1,000 years ago, if you describe to them a hydrogen molecule and an oxygen molecule, 2 hydrogen and 1 oxygen molecule put together, they wouldn't think of water. And yet they'd be thinking about H2O, but they wouldn't be thinking about water, even though H2O and water are the same thing. So they are the same thing, but they're also kind of not, depending on what sense you mean the term.
Exactly. So, and I'd say Frege has his own technical definition of sense, but I wanted to draw on this just as an example of how the kind of logician's obsession with specificity can be very helpful for either clearing up arguments that you kind of think, oh, that's a bit spurious, but I don't quite know why it's a bit spurious, or potentially solving problems or opening up new avenues to solving philosophical problems that might not have necessarily been spotted before. I think that another, people online are people online are often very keen on the idea of kind of logical fallacies. If you scroll through a lot of comment sections on philosophy videos, you see people having arguments. You might say something like,
fallacy, that's a fallacy.
And I think that this is, in some sense, sort of attempting to identify unsound logical structures. These are the logical structures that we want to avoid. And I think that invalid logical structures. And one of the benefits of potentially, just dipping your toe into something like even just propositional logic and maybe a tiny bit of predicate calculus is that it kind of becomes immediately clear why a fallacy might be a fallacy.
Yes.
In theory, any formal fallacy is just reducible to non sequitur, so it just doesn't follow. So, imagine affirming the consequent, I'm pretty sure is the name for the fallacy where you say A implies B, not A, therefore not B.
Okay, so let's slow down for a second. We're talking about logical fallacies.
Yes, yeah.
And affirming the consequent. Is that what it's called? Where you say, so if A then B, and then you say not A, therefore not B, which doesn't actually follow.
Yes, that doesn't follow.
So for example, if it's raining outside, then I'll get wet. It's not raining outside, therefore I won't get wet.
Yeah, so you think that, there might be some kind of Machiavellian person outside there with a bucket waiting to kind of tip.
Yeah, or I could just go and have a shower.
Exactly, yeah. That's a much better example.
But it kind of casually, it kind of feels like it should. And there are contexts where you can imagine if somebody said really quickly like, oh, well, if it's raining, I'm going to get wet. And you'd look and go like, but it's not raining. So, oh, okay, cool, I won't get wet then. It's like, all right, nice. When actually, like, oh, slow down there. And in that circumstance, like, maybe it doesn't matter. Like, you kind of, you know what I mean. It's fine. But in an argument where you're like arguing for God's existence or meta-ethics, which is really important, you could be technically that doesn't follow. We need to be more careful.
Yes,
and you're not going to be able to spot that unless when you hear somebody say, "Gosh, I'll get wet if it's raining," like outside. Like, if you are not able to translate that into if it's raining, then I will get wet. It is raining, therefore I will get wet. It is not raining. If you can't sort of do that translation in your head, you won't spot that it's not.
Yeah, at the very least,
logical.
It's going to be slightly harder, right? As in, I imagine that people.
Yeah, you can still spot it.
You can still, but it's just a more systematic way of approaching it.
It's much easier to spot it. Yeah.
Yeah, and the important thing here is that the conclusion isn't guaranteed by the premises. You can imagine a situation where all the premises are true, but the conclusion is false, which is the logical definition of validity.
Okay, because this is really important, right? So, what does logic apply to? Like, we often talk about logical arguments, right? Is it like logic is a thing which applies to arguments? Does it apply to sentences? Does it like what is logic?
I would suggest that
used on
logic applies to reasoning, and quite broadly construed. If you're dealing with something like propositional logic, its subject matter is propositions. If you're dealing with something like predicate logic, its subjects are going to be predicates and objects and the logical relations between them. In theory, you can kind of say, well, any discourse whereby we want to guarantee the truth of our conclusion from our premises is going to be governed by some kind of logic. It is, or at least it claims to be, the kind of normative rules of thought.
Yeah.
What the original kind of intuition that Aristotle's having, or one of them, when he kind of founds logic in the Western philosophical tradition, is basically just how do I know that I'm thinking well? How do I know when I'm thinking poorly? And there are plenty of other non-logical aspects to that question. So you could say, well, one of the things you might want to figure out if you want your thinking to be precise would be something like, well, I ought to define all of my terms very precisely, because if I don't, then I'm not going to be quite clear on what I mean. And that's not a matter for formal logic, but it's nonetheless a kind of general rule of, or general bit of cognitive hygiene, I suppose. And but logic, I would say, tends to deal more with the idea of reasoning. So relationships between statements, propositions, terms. Basically, if this thing is true, what do I know from that?
Yeah, like what can you derive from one thing? What can you draw out of it? And so there's a term that you've used a few times now, which is the term valid. You've also used the word sound, which does not mean the same thing. So let's take an argument like modus ponens. So if P, then Q, P, therefore Q. The reason we use letters there is because it doesn't matter what you plug in, it's still going to work the same, right? So you could say, if the sky is red, then my bathtub is filled. The sky is red, therefore the bathtub is filled, right? It doesn't matter what sentences you put in. If P, then Q, P, therefore Q. That argument is an example of a valid argument. What is validity? What is validity? I was saying the word valid, so I went to say, like, what is validity? What is validity in a logical argument?
So validity in a logical argument is there a situation whereby the premises of my argument are true and yet the conclusion is false? So, what was your example there again? Sorry.
Let's pick a better one. Like, if it's raining outside, then I'll get wet.
Yes, yeah. So
premise 2, it is raining outside. Conclusion, therefore, I will get wet.
Yes. So if you accept the first two statements, you are bound by consistency to accept the final statement. There's not a situation where the first two statements are true, yet the conclusion is false.
Now, crucially, I've got to separate this out because, like, we just talked about a logical fallacy, right? This is not the same thing. So earlier we had this argument, which was, if it's raining outside, then I'll get wet. And it was then, it's not raining outside, therefore I will not get wet.
Yes.
That's invalid.
Yes.
We're doing a positive modus ponens. So it starts with the same first premise. If it's raining outside, then I'll get wet. But this time the second premise is, it is raining outside, therefore I will get wet. And that whole first premise can be thought of as one. So the first premise is this if-then. If it's raining, then I'll get wet. So let's say that's true. Let's say it's just true that if it's raining, I'll get wet. Then premise 2, it's raining. because it's true that if it's raining, I'll get wet, it means that I must get wet, right?
Yes, exactly.
And that's what validity is. It means that essentially the conclusion is guaranteed by the premises.
Yes. And then that kind of guaranteed is then cashed out as I can't, there's no situation where the premises
can be true and the conclusion. And it's important that it's defined in that way. We'll get into that in a moment. But the technical definition then of validity, an argument is valid if there is no sense in which the premises can be true and the conclusion be false. If it's impossible for the premises to be true and the conclusion false, it means it's valid. Importantly, this does not mean that the argument is sound.
Yes, or even in any intuitive sense, good.
Yeah, it doesn't mean that to say an argument is valid does not mean that its premises and conclusion are true.
Yes, it simply
just means that if the premises are true, the conclusion has to be true.
It denotes something about its structure. We can kind of broadly, logicians often think about this in terms of syntax and semantics, but we can kind of just think about it in terms of form and content for the sake of argument today. So we can think about our previous fallacy there, affirming the consequent, is a fallacy of form. It's a formal fallacy. It is an error in the reasoning structure at play here.
It's not about the content. It's not about the actual.
No, exactly. And you can have
about the structure.
You can have an unsound argument.
Right. So just to be clear,
valid. So
soundness, if an argument is sound,
it
means it's valid and also true.
Yes, exactly. So there are kind of two definitions of soundness, and rather unhelpfully, the one that I think is most useful is also the less popular one. So the most popular use of soundness is to say an argument is sound if and only if it's valid and also all of the premises are true. And that will guarantee the truth of the conclusion, whatever's the case, right? So let's say all men are mortal, Socrates is a man, therefore Socrates is mortal. Not only is that a valid argumentative structure, it's also sound. The other way that some people use sound is just to denote that premises are true without saying anything about validity. Unhelpfully, that's not standard usage, but I also think it's very popular.
Yeah.
Unhelpfully, that's not standard usage, but I also think that it is in some sense more useful because then you can say an argument's sort of sound but not valid.
Yeah, so we got to slow down for a second because there's a lot of words being thrown around. We're talking about this concept of validity, and I think it's really important because it comes up a lot to distinguish validity and soundness. They're often used interchangeably. They're not the same thing. So just to give an example, let's take an argument which is not sound but is valid. So I'm going to produce an argument which has a valid logical structure but is not true. So premise one, if it's raining outside, then Joe Folly is a type of bird. That's my first premise. Premise two, it is raining outside. Conclusion, Joe Folly is a type of bird, right? Because the premise one is if it's raining outside, then Joe Folly is a type of bird. And it is raining outside, therefore Joe Folly is a type of bird. That is a valid argument because there's no way for those premises to be true and the conclusion be false. So it is valid. But clearly those premises aren't true. It's not true that if it's raining outside, you're a type of bird. It's also not true that it's raining outside. So the argument is unsound, but it's still valid. So there's a separate question as to whether a logical argument is valid. Does the conclusion follow from the premises? It's then a separate question whether those premises are actually true or not.
Yes, logicians tend to be much more interested in validity than soundness because, if you're a logician attempting to craft or refine a logical system, you tend to want that logical system to apply to almost anything. You can plug almost anything you want into the variables, your arguments will still work. That's why they're kind of mainly concerned with validity rather than soundness. This is sometimes called the ideal of topic neutrality for logic, where if you at home happen to be designing a logical system, you ideally want the rules to be broad enough that you can stick literally anything in the structures and it will still work. That's kind of one of the ideals, historical ideals for a logical system.
So just to be clear, when people are arguing on the internet, if somebody says, for example, something like that, if somebody says, if the universe began to exist, then it must have a cause, and the universe did begin to exist, therefore it has a cause, and somebody goes like, oh no, that's invalid because the universe didn't have a cause. No, it's not invalid. It's unsound.
And I do
stop using the word invalid to describe arguments that are false. Only use the word invalid to describe arguments which are structurally, like the conclusion doesn't follow from the premises.
And this may seem kind of nitpicky, but it does tell you something very, very helpful about what it would take for the argument to be true. Because say you have an invalid argument in front of you, then effectively you can just kind of stop there, right? It may be that the premises are true, but it doesn't matter because the conclusion doesn't follow from the premises.
Yeah.
However, if you're saying that an argument is unsound, but nonetheless that it's valid, that does tell you something. It tells you that the denial of that argument is based on your assertion that one of the premises is false. And then you can identify which premise is false. Here you might dispute that the universe had a beginning, for example.
Yeah.
That was, this was Aquinas' argument against, the Kalam cosmological argument. Though, of course, it wasn't known as the Kalam cosmological argument then. This kind of linear cosmological argument. Aquinas basically said, no, I don't think that it's guaranteed by by natural reason that the universe had a beginning. He did think that it had a beginning because of the Bible, but he didn't think that you could know that just through reason. And so that would be, we think about what's Aquinas doing there. Well, he's saying, I'm questioning one of those premises.
I'm saying it's a valid argument, but
so it's a valid argument, but I'm
unsound.
Exactly. Or it's potentially, at the very least, I'm not confident enough to grant you all of those
And like
premises.
you say, importantly, if an argument is invalid, like you said, you can just stop there. So you might waste a lot of time, because if I made an argument that said, like, all Blogarts are Fogarts and X is a Blogart, therefore X is also a Flogart, you might start asking me like, oh, well, what's a Blogart? What's a Flogart? How do you define that? What? But you could actually just like look at the argumentative structure. And if I've said something invalid in the structure, you don't even need to bother with that.
Well, at the very least, that argument's wrong. It might still be that their conclusion happens to be true, but it won't be guaranteed by an invalid argument.
Exactly. So it's important to separate out validity and soundness. There's a... Can we talk about the concept of ex falso quod libet?
We can, yeah. I think that it's ex falso quod libet.
Is that going to be too much?
No. Let's give it a go.
The definition of a valid argument is, as we've said, that there's no sense in which the premises can both be true and yet the conclusion be false. So, like, the reason why contradictions, or one reason why contradictions aren't allowed in logic, like, why can't you have a contradiction? Why can't I say premise 1, it's raining outside, premise 2, it's not raining outside? One of the reasons you can't say that is because of this principle called ex falso quod libet. From the false, anything. And as far as I understand it, the reason that what that means is that from two contradictory premises, anything logically follows. So let's take this argument. Premise 1, it's raining outside. Premise 2, it's not raining outside. Conclusion, therefore, I have a cup of tea in my hand. Is that a valid argument? You might listen to that and go like, no, of course that's not valid. That doesn't follow. But the definition of a valid argument is that there's no interpretation under which the premises can both be true and the conclusion be false. And for that argument, there is no interpretation in which the premises can be true and the conclusion be false, because there's no interpretation in which the premises can both be true, because they contradict each other. So if the definition of a logical argument is no interpretation under which the premises can be true and the conclusion false, then that argument, it's raining outside, it's not raining outside, therefore there's a cup of tea in my hand, is valid.
Yes, and if you wanted to get just briefly dip our toes into something slightly technical, in some logical systems, ex falso quod libet is taken as read. It's like a kind of, it's just a rule of the system. For others, they will start with something called the disjunctive syllogism, which is the idea that, say I've got A or B, and in logic, or is inclusive. So A or B is true, if A is true, if B is true, or if both A and B are true. The disjunctive syllogism, which some logical systems will take as primitive, others will prove this through ex falso quod libet. But it's far more intuitive if you start with the disjunctive syllogism for the purpose of kind of getting an intuitive grip on what ex falso quod libet, how you might conceive of that. The disjunctive syllogism states that if you've got A or B, and I've got not A, well then, by definition, I have to have B. Because A or B is true if A is true, B is true, or both are true. I know that not A is true, and so A is not true. And so I'm left with B.
So just to be clear, in logic, an or statement, so like, P or Q, that whole statement, P or Q, is true even if just only one of those is true.
Yes, yeah, or both of them is true.
Yeah,
so it's inclusive. And
so the statement, there's a car outside or it's raining,
it's
true. Say there is a car outside but it's not raining, it's still true that there's a car outside or it's raining.
Yes, and if we have this inclusive or, that intuitively a number of things basically follow from that. One of which is this disjunctive syllogism. If I've got A or B, then if I have not A, then I've got B, and if I've got not B, then I've got A.
So premise 1, there's a car outside or it's raining.
Yes.
Premise 2, it's not raining. conclusion, therefore
there
there's
must
a car
be
outside.
a car outside. Another consequence of having an inclusive or is that if I know that P is true, like I just know it, then I know that P or literally anything else is also true.
Yeah.
So if Alex is sitting on a brown chair, or gorillas are rampaging through the streets of London as we speak, is true because one of the disjunctions is true. Now, how this allows us to get an intuitive gloss of ex falso quod libet, and again, I want to kind of emphasize that this is different in different logical systems because some define the disjunctive syllogism through this, or we can get it if we assume the disjunctive syllogism, is that, say we've got P and not P. So we've got our contradiction. We've kind of somehow ended up in this situation where we've got a contradiction. Well, I can assume P and I can introduce literally anything else. P or literally anything else. So P or gorillas are rampaging through the streets of London. Then I have not P. So via the disjunctive syllogism, I can get rid of P or gorillas are running through the streets of London, and I'm just left with a proof that gorillas are running through the streets of London. So that's kind of an intuitive gloss.
So it's a consequence of like this system of logic that if you allow a contradiction, literally anything follows from it.
Yes, and as I say,
from a contradiction, it follows that gorillas are rampaging through the streets of London. From a contradiction, it follows that Spain doesn't exist. From a contradiction, it follows that Spain does exist. Like everything follows from a contradiction. It's also known as the principle of explosion, right? Yeah. Because it just explodes into proving absolutely anything, which is why, given the system of logic that we're talking about, you can't allow contradictions. Contradictions are not allowed, because if you allow a contradiction, the whole thing just blows up.
Exactly. And I think that a nice way of, again, because you look at the rule of explosion, you think, well, what on earth is going on there? Like, why it does not seem intuitive at all that from a contradiction anything follows. A way of, again, just kind of intuitively getting an idea for this is it's a bit like saying, well, if that's true, then I give up. Like anything can be true if we admit of contradictions. We've given up any kind of restrictive principles on what can be the case, and thus logic is no longer gets any purchase. Now, there are formal logical systems that will get rid of ex falso quod libet and attempt to accommodate contradictions in some sense. These are called paraconsistent logics, and I'm not overly familiar with them, but I just wanted to point out that they do exist.
Yeah, it's worth re-emphasizing that there are different forms of logic, different kinds of logic, different systems of logic that interpret different things differently, because there are all kinds of problems for creating a system of logic. It's a bit like how in mathematics, like you're not allowed to divide by zero. That's like a rule, but that seems to be a consequence of like our conception of zero. Like it's kind of, it's true that in our system of mathematics, you can't divide by zero. But it's like, it's just this kind of like rule that exists, because if you do divide by zero, then you end up with all these paradoxical conclusions. So
it's undefined.
So we just accept as a rule that you can't do it, And similarly, in some logical systems, we sort of have a similar approach where we say there are rules, like you can't have a contradiction. Why? Because if you do, anything follows. And it might have been a bit too technical, and it's kind of hard to follow. So if anybody's interested, just Google, ex falso quod libet, or from the false anything, or the principle of explosion, and just look at it written down, look at a proof. But basically, if you allow a contradiction, according to the laws of logic, anything follows from a contradiction.
And this is kind of a good reason to not get mired in contradictions,
to not allow contradictions, which is also why if you want to disprove an argument, if you want to show that something can't be the case, one way to do that is to show that it entails a contradiction.
Yeah, so that's kind of a reductio ad absurdum. Or I think that other people have called it a reductio per impossibile.
Yeah,
which I think is like, I think it's just a slightly snazzier term.
Yeah, I think it might be, but whatever you want to call it, if somebody holds two ideas, if they say like, well, I don't know, I don't want to give an example because it might get complicated, but if somebody holds two ideas and you want to show that like they contradict each other, then you have shown that they can't hold both of those ideas. Yes, or if you show that something that they believe necessarily leads to a contradiction, then since we're not allowed contradictions, that's a way of showing that that it doesn't exist.
And it's really interesting how people have kind of, Aristotle's justification for the law of non-contradiction is fascinating. Because I know that you're very interested in kind of global emotivism as an idea. Well, Aristotle's justification for not allowing contradictions is eminently pragmatic. He sort of goes, well, I don't know, man, try and think a contradiction. Try and think in terms of contradictions. You absolutely cannot do it. So, there is a sense in which one of the interesting things about the philosophy of logic is that because you're at this kind of incredibly abstract level where you're almost trying to get a grip on the laws of thought, you end up having to say a fair amount is just self-evidently true. The Stoics called their logical rules the indemonstrables for this reason, because they basically sort of went, well, if you think that if P then Q, P therefore Q isn't a good argument, I don't know what to tell you. Like I can't show that it's the case. I can just point to it and sort of say
it's just there.
It's just there. Like, come on, it's self-evident.
Yeah.
I don't know how to think apart from using these rules.
But logic also applies. So we've been talking about logical arguments, right? So like these rules of inference. If P then Q, P therefore Q. Yeah, that has to be true. But there are also like more atomic logical rules that we accept, not as the result of some kind of argument or inference, but they just exist as they are. These are like what oftentimes are called like the foundational laws of logic. So one of the most important of these is the law of non-contradiction. A proposition can't be true and false at the same time. That's not an inference. That's not an argument. That is just a statement. Something like P, the proposition P cannot be true and false in the same way at the same time. Like, what is that? What is this axiom of logic? Is that like, do we reason our way into that? Is it a prerequisite of reason? Like, how do we justify these axioms?
Well, as I said, I think this is one of the exciting things about the philosophy of logic is that if you're trying to ground logic, you can't appeal to logic. If you're trying to ground in something prior to logic, that's really, really hard. And as I say, an awful lot of ancient logicians, and it's a lot of modern logicians will just kind of say, like, try and present to me a way of thinking that allows me to have contradiction.
Somebody might just say, okay, well, I'll imagine that it's, maybe P and P can be true and false at the same time. Cool. Okay, right, let's try that for a second. So you are accepting that a proposition can be true and false at the same time, right? So you think it's true that a proposition can be true and false at the same time. I think it's also false.
Yeah, it's
false. So it's false that a proposition can be true or false at the same time, which is what I was arguing all along. And you say, no, it can be true or false at the same time. Like, yeah, but if it could be true or false at the same time, then that can also be false. So it's true and it's false. So
another way of kind of attempting to justify this would be to say something like, okay, go out and kind of live your life and never infer from learning something that its opposite could not be true.
Yeah.
You're just going to run into an awful lot of difficulties.
Yeah, it's like that's just not how the human brain works. So these fundamental laws of logic, like the law of non-contradiction, as it's called, seem to be bedrock. They seem to be foundational, and these are the laws of logic with which we use, with which we sort of construct arguments and thought, and sort of have an ability to use reason. But like, I don't know, like, what are these laws of logic? Like, where do they come from? Are they psychological concepts? Do they exist in the universe? Like, did they exist before humans existed? What do you think they are?
So I think that probably one of the best ways of going about attempting to answer this question is to begin by ruling out the kind of things that they probably can't be. So they can't merely be descriptions of how we in fact do think, because we think non-logically an awful lot of the time. In fact, I think one of the really interesting parts of, Kahneman and Tversky's work in psychology is just to demonstrate that, a lot of the time we're not thinking logically. We're thinking heuristically. We're drawing from association and emotion. We're not, man is a rational animal in the sense that he can do rationality, but we're not perfectly rational. That's not by any means our dominant mode of thought. So this was summed up in a sentence by the American logician and pragmatist philosopher C.S. Peirce, I never quite know which way to pronounce it, where he said that logic is a normative science, which is to say it's not simply describing how you think, it's describing how you ought to think. And cashing out that ought philosophically is incredibly interesting because, a lot of people are very comfortable, for example, saying something like, well, moral oughts, they're a bit fishy. Like, kind of, I'm happy to be a moral anti-realist. I'm happy to be a normative anti-realist in that sense. But you go take something like logic, you say, well, can you be a normative anti-realist about logic? That strikes me as something that's at least most people are significantly less fond of doing
If
because
somebody,
it leaves you with a lot less.
if somebody is like being illogical, like literally illogical, and you tell them like, hey, that's not logical, and they go, I know, like, so what? You want to say, well, what do you mean so what? Like you should be acting logically, and they're like, why? It's like, that's just how thinking is supposed to be done. That's just what it. And you can't say, well, that's just what thinking is, because they're not thinking logically. So it's not what thinking is, but you want to say that they're incorrect. Well, to say that they're incorrect in the way that they're doing something is to say that there's a way that they should be doing it, that they're not.
And, you can kind of try and cash this out as a hypothetical imperative. Something like, if you want to preserve truth, then you ought to try and think logically in this kind of, narrower sense of what logic means. And, that does leave it open for somebody to say, I'm not interested in preserving truth.
Or they could say, I'm also interested in preserving truth.
Yes.
I'm interested in preserving truth, and I'm also not interested in preserving truth, because I've abandoned the laws of logic.
At which point you, at the very least, can say, well, clearly not interested in preserving truth, whatever you say.
And you'd want to say to them, like, your thinking is going wrong.
Yes, yeah. As in your thinking has become detached from the kind of inferences that preserve truth from a set of premises to a conclusion.
So there seems to be this sort of normative undertone.
Yes, which is I should say, normativity is significantly more commonplace than we often give it credit for. Language.
What do you mean by normativity?
Normative is oughtness, is the kind of way of putting it. Which I don't necessarily mean kind of moral oughtness. My point is that actually normativity is a lot more commonplace than you might think.
And it's not just in the ethical sphere.
It's not just in the ethical sphere. Language contains within it a sort of element of normativity, even though, language tracks how people actually use language. It is also possible to use language incorrectly. So if I was to say, the what's that line from the Jabberwocky? The slidey toves doth gyre and gimble in the wave, to sort of mean I fancy a cup of tea, then I'm using language incorrectly, by which, we're kind of implicitly assuming a function there, which is that the purpose of language is to communicate. And I'm using language in such a way that I am so unlikely to be understood that I'm essentially going against the assumed function for language. And I think we can...
So that's normativity, because you should be using language differently, but it's not ethical. It's not
my point is that
immoral.
My point is that it can at first be sort of very mysterious when we say, oh, you ought to be thinking like this, or you're kind of using language wrong. It can at first seem very mysterious. I think that mysteriousness is, in some sense, a confusion of language.
So the concept of should and should not, or ought and ought not, can be separated from morality.
Of course, yeah, and we can partly do this because we can quite naturally define a function for a lot of language. We can quite naturally define a function for logic in a way that allows you to have this hypothetical part of the imperative. You can say, if you want to do this, then you ought to do this. If you want to be understood, then speak in such a way such that, to the best of your knowledge, people will be able to understand you. If you want to preserve truth in your reasoning, then reason according to these logical rules that we have found preserve truth. That's significantly less, to my mind, mysterious than the kind of ethical, you ought to do this, and it doesn't matter any kind of ifs. No ifs, buts, or maybes. You really ought to do this.
In the context of logic, we've said that logic applies to like arguments and sentences and their relations, but it also obviously involves truth. Like logical validity requires, if the premises are true, the conclusion is true. Soundness requires the premises being true. Logic doesn't seem to apply to expressions like, hooray or go over there. Logic applies to the kinds of statements which have truth value, which can be true or false. So in the context of talking about logic and learning about what logic is, what is truth and falsity?
It's complicated. And I suppose it probably depends on who you ask. One of the really fascinating findings of a guy called Alfred Tarski in the 20th century was that you cannot define, for an awful lot of logics, you cannot define truth within the scope of the logic. You have to appeal to what's called a meta theory or a meta language to define truth within the object language, which is the logic you're talking about. So in terms of a kind of more philosophical sense, I suppose it collapses to the question of what you think truth is in philosophy. Do you think that it is a matter of correspondence? Some people certainly did. I think Frege has a kind of... Actually, I don't know. I probably wouldn't say that. But, because he also critiqued a lot of correspondence theories. So, but a lot of people would say that that truth is cashed out as correspondence between a proposition and a state of affairs in the world. Some people would say that it's deflationary. So when I say snow is white is true, I'm saying nothing more than snow is white.
Yeah. So for some people to say snow is white is true is to say that that sentence snow is white corresponds with the thing about the world that snow is actually white.
Yes, but to say that it's deflationary...
Deflationary means it actually adds nothing. So there are different ideas of what truth actually is, right? But also within logic, like we need to be able to say that, okay, whatever your theory of truth is, if a premise is true and the second premise is true and the conclusion follows from the premises, then the conclusion is true. There are some ambiguous cases as to whether to call something true or false, right? So the famous example is the sentence like the current king of France is bold. Right now, like the current king of France is bold. I'm going to ask, like, is that true or false? And obviously the problem is that France doesn't have a king. But I'm like predicating something of this non-existent king that he's bold. So it seems like it's false that the current king of France is bold. I want to say that's false. But it doesn't seem right to say, no, the current king of France isn't bold. Like that's because I'm sort of referring to an object that doesn't exist. So for a statement like that, is it true?
So
is it false? Is it undefined?
So this is statements like these. That particular one was kind of analysed quite heavily by Bertrand Russell and his theory of definite descriptions. The specific statement, the present king of France is bald, as there exists a present king of France. There exists only one thing, the present king of France, and that thing, the present king of France, is bald. It's kind of very, very broadly and non-technically kind of roughly what the theory of definite descriptions states. The general class of statements where it's very difficult to tell whether they're true or false because in some sense they're underspecified or they decompose into other statements are known as exponable statements. And these have been a problem since basically forever in logic. They're kind of one of the classic logical difficulties. They cause a lot of headache for some medieval logicians. And, their kind of classic example is stuff like, when did Socrates begin X, Y, and Z? Or like, actually, you know what? Teenage boys are like absolute masters at coming up with exponable statements. I think that the classic one, when I was a teenager, was, does your mum know you're gay? and I don't know if you've seen it. There's this, because this is a fantastic Instagram reel for anyone that's interested about the kind of logical decomposition of exponable statements, which is that there's a guy and he says to somebody across the table, when I click my fingers, you'll forget that you're ever gay. And then he clicks his fingers, and then the guy goes, what are you talking about? I was never gay. Yeah. He goes, see, what? And I remember thinking about this when I was a teenager a little bit. It's sort of, well, this seems like this happened to you a lot, did it? Yeah, of course. Look at me. This is exactly the kind of insult that is finely tuned to my presentation and manner. And this, the statement like, does your mum know you're gay? Effectively decomposes into, proposition one, you are gay, and proposition B, your mum knows about it. So
yeah, because there's no way you can't say like, yes, my mum knows I'm gay. But you also can't say, no, my mum doesn't know I'm gay.
Well, that is if you're not gay. If you're gay, then you have a perfectly sensible answer.
Yes to at least one of those. Yeah.
The idea is that it's got a kind of nested claim within the broader structure.
Right.
And that's, an exponable statement. So, if any of you are watching and people say this at school, you can say, I'm afraid, good sir, that's an exponable statement. And as a result, I will decompose it into its separate propositions and choose to deny or affirm them individually. And I'm sure that the bullying will stop after you say something like that. But, I just kind of use that as an illustrative example to show that, this is... exponable statements are very, very commonplace. They're kind of all over the shop, and Russell is dealing with just one of them. And if you want to give a kind of truth functional analysis where you maintain your sharp division between true and false, then you tend to decompose exponable statements into.
So wait, so how would a logician approach a question like that?
Well, they would say there's an implicit claim within the present king of France is bald, that there is a present king of France, and that he is bald.
So would they say it's false?
Well, they would say it's false.
So it's false that the current king of France is gay. And if I'm sorry,
Well, that would also be an explainable statement.
That would be
that also works, because the reason it's false is just because there's no present king of France.
Okay, but then then if I asked you, Joe, like, does your mum know that the King of France is gay? Would that same logician say yes or no, or would they just reject the
they'd
question?
say it was false. They'd say that one of the claims, well, if they were giving a kind
they
of
would say no.
decompositional analysis of this, they would say that one of the implicit claims is that the present king of France is gay,
Because
and
really,
that's false.
really the phrase would
And
not
so-
be like, my mum doesn't know the King
Yeah,
of France
exactly.
is gay.
So we
It'd be
can
like,
think of
it
this-
is not the case that my mum
Yes.
knows the King of France is gay.
Yeah, so that they would say that this is a conjunction of two claims. One,
Yeah.
the present king of France is gay or bald, or literally whatever property you want to assign to the present king of France.
Yeah.
And my mum knows about this. And of course, the conjunction of those is false, because the left hand of it is false. And that, a conjunction is only true if both sides are true. So that's how that would be one way of
But suppose I
decomposing
said,
this.
like, the current King of France is non-existent.
Yes.
That's true.
Yeah, but that would be analysed as there does not
There
exist
does not
an
exist.
X such
and
that.
this is where the language of logic becomes really important, because you need to be able to translate a statement like that into a form that makes sense. So whereas I said, the current King of France is bald, and the current King of France does not exist. That kind of sounds like I'm saying the same kind of thing twice, but I'm not. Because in the first case, I'm saying there is a King of France such that he is bald. And in the other case, it's like there is not a King of France.
Yes, exactly. One way of thinking about
But
this
that
is-
way you can see they're not the same kind of statement. But
Yes.
that's to do with how you formalize the sentence.
And I think that intuitively, a lot of listeners may have encountered this when they're looking at the ontological argument. Famously, one of the responses to the ontological argument is that existence isn't a predicate.
Mhm.
And this is just kind of the same sort of thing, saying that, existence isn't a property of the thing. When you say the present king of France does not exist, you're not saying that there is a present king of France and he doesn't exist.
Mhm.
That's absurd. You're saying that there is no present king of France. Those statements are equivalent.
Mhm.
Yeah, so that's kind of, but these are another, this does just illustrate another incredibly useful tool for logical analysis, which is that you can take statements that at first seem very, very confusing, and you can break them down into parts and then get a clearer grip on what exactly they mean. Alternatives, because there are logicians that hold that there's genuine vagueness in the world, or that there are statements that are genuinely of indeterminate or gradable truth value, and these are fuzzy logicians.
Fuzzy
well,
they're not
so-
fuzzy logicians. They're logicians
in fuzzy logic,
exactly. That's a
And,
better way of putting it.
and or many-valued logic.
So what is
another.
fuzzy logic? What is that?
So fuzzy logic is a form of many-valued logic. So many-valued logic, very, very broadly, is just any logic that has more than two truth values. So there's a Polish logician, and I can't pronounce his name, but it's spelt like it's pronounced Lukasiewicz, and it's definitely not pronounced like that. But it's one of the ones I've only seen written down. And he came up with lots and lots of different many-valued logics. Probably the two most important ones are a three-valued logic, where you've got true, false, and half, or 0, 1, and half, because obviously he's kind of assigning it in numbers, and an infinite valued logic, whereby you have 0 and 0.1 and 0.01, and you've got literally the whole.
You've got this continuum
you've got-
between 0 and 1.
Yes, you've got the whole-
0 is false, 1 is true, and you've got this.
Yes, you've got this entire continuum in between the two.
What do you
parts.
mean then? So take a form of logic, of fuzzy logic, that says that there are three kinds of truth value. There's 0, 1, and 0.5. Like, so 0 means it's false, 1 means it's true. What does 0.5 mean? Like,
So,
what does that actually mean?
well, the logic itself would not impose an interpretation on that. It's just a series of rules. But you might think of that as, depending on what interpretation you're using, you might think of that as indeterminate. You might think of it as vague. You might, I'm sure that there are some interpretations, but it's just like I don't know. There are, the infinitely many valued ones. You might think that you might use that to, if you were to embed that in something like a doxastic or epistemic logic, you might want to use gradability to represent confidence or something like that. There are types of fuzzy logic that mesh quite well with probability theory, so some people want to use them in that way. But the interesting thing about fuzzy logic doesn't denote a single logical system or even a single definition for logical connectors. It denotes more of a kind of general vibe, I suppose. So it's any logic that has this kind of continuous truth values between 0 and 1. and the actual definitions of the connectives like and or implication or by implication will be different. They will cash those out in slightly different ways, and as a result, they'll end up with slightly different values for their sentences. But yeah, it's a logic that is quite often used to deal with vagueness or uncertainty or something like that.
You just mentioned epistemic logic. What's that?
So epistemic logic is well, let's start with modal logic, because epistemic logic uses a lot of the same tools as modal logic. Again, I'm keeping things very, very non-technical. Modal logic is a logic that is aimed to study necessity and possibility. So, we talk about this kind of thing in philosophy a lot. You might say, well, is X necessarily true? Is it merely possibly true? Is it true in this world? And modal logic allows you to talk about this kind of stuff. So,
the logic we've been talking about so far is like a statement is either true or false.
Yes, that's classical logic.
But a statement can be true. Like it's true that 2 and 2 is 5. It's also true that this chair is brown.
Yes,
but it seems it's not necessarily true that the chair is brown. It could have been blue. But it seems necessarily true that 2 and 2 is 5. 2 and 2 is 4. So there seems to be this different kind of truth. There's necessary truth and there's possible truth. And so modal logic is attempting to take that into consideration.
Yes. And
so it's the logic of possibility and necessity.
Yes, exactly. And so the way that this is cashed out on a kind of model system, the kind of the model theory for modal logic uses something called Kripke modeling, which I assume was invented by Saul Kripke. I actually don't know, but it's called Kripke modeling, so you kind of hope so. And the idea is that you have a world where you intuitively live at. So you've got a world where Alex lives, and then you've got a bunch of possible worlds around you. And some of those, and what is necessary is the stuff that is true in all of the worlds that are accessible to your world. So this allows you to define different notions of possibility. So say you wanted to restrict your notion of possibility to restrict your notion of accessible worlds to only those worlds that share the same physical laws as your world. Well, then you've got a very, very neat, very systematic definition of physical possibility. Say you wanted to examine possibility but keep a few different propositions fixed, then you would effectively say, right, well, let's only have those worlds be accessible to our current world where these few propositions are fixed. And you can kind of play around with the modeling a bit like that. There are different restrictions on how the relationship of accessibility works, which gives you slightly different modal logics. But again, I don't know.
So starting simply, like we're using these ideas of other worlds. We're not talking about like a multiverse, like physical universe existing. It's just a way of thinking, right?
Yes,
so like there's another possible world that could have existed where like that table doesn't exist. So we just sort of conceptually think of it as like there is this possible world that is the same as this one, except that table doesn't exist.
Yes, we can think of them as well, for the purposes of discussion here anyway, we can think of them as just sets of propositions.
Yeah.
So we think of them as, you've got a series of propositions.
A consistent
that are true.
Set of propositions.
Yes, well, depending on who you ask. There are people that do impossible world semantics, where in order to model impossibilities, they will allow for certain worlds to have inconsistent sentences.
Oh. There are also modal realists who believe that actually David Lewis who think that these possible worlds are actually real worlds. They actually like truly exist. That's a little bit fringe, but it's usually just a way of thinking about the world. So if I want to say, like, one way of me saying it's possible that I could have not existed, that was possible, I can rephrase that as there is a possible world in which I do not exist.
Yes, and that would allow you to treat that sentence in a modal logic rigorously and comfortably.
Yeah.
This same framework ends up being really, really handy for a whole bunch of other things. So, classic question, what do you mean by believe? Comes up a lot at the moment. And a doxastic or epistemic logician would look at that question and say, I know exactly what I mean by believe. By believe, I mean it's true at every possible world that is accessible to me. Which is effectively saying, imagine that you're an agent living at World 1, and you've got a series of worlds that you're considering, let's say, to give it a kind of psychological interpretation. Well, then, everything that's true at every world that you're considering is effectively what you believe, is the kind of reasoning that an epistemic or doxastic logician might use to justify their kind of their usage of this framework of necessity to deal with things like belief and knowledge. They're not saying that, you know, they're using the same logical apparatus, but they're giving a different interpretation to the symbols. And this is, I think, again, something that really illustrates just how handy logic can be, is that sometimes you design something that's to be used for something totally different to a new usage, and then suddenly you find that actually this kind of broad idea of necessity, if you kind of relativize the interpretation to an agent and you don't think of possible worlds as possibilities, but instead as worlds that this agent could be considering, then actually you have a very neat formal system for dealing with belief and knowledge.
Take that, Jordan Peterson.
Well, and that's just one way of dealing with belief. You know, you could talk about it, a whole series of other ways. But I think that this is at the very least a very good way of formally treating belief.
So we've got kind of, and this is back to what we said at the beginning. It's beginning to sound like we've got different logics or different kinds of logic depending on what our task is. If we're interested in epistemology, we might use epistemological logic. If we're interested in possibility, we might use modal logic. If we're interested in sentence construction, we might use predicate logic. And so when we spoke earlier and you were talking about how there might be like different kinds of logic for different kinds of circumstances, might have sounded like, wait, what are you talking about? Surely there's logic and there's non-logic. But I hope people can begin to see how the way we construct a logical system can be very different. I mean, the whole conversation we had about P's and Q's and if that and that and logical fallacies didn't even consider or incorporate the concept of possibility versus necessity, for example. And so you need this sort of other way of thinking about logic, modal logic, in order to incorporate that.
Yes, and in some sense, you can still have these different logics, even if you are a logical monist, and you think that ultimately there is one true way of thought.
Yes.
You could still say, oh, you know, these are still very useful tools, but ultimately there is a
logical theory of everything.
Yes, exactly. And different people have posed different kind of logics to fill this role. I think that Owen Griffiths and Alexander Pazot's one was in first-order infinitary logic, which is very interesting, but I can't remember how exactly it functions, but I remember enjoying it at the time. And, you know, as I say, there can be different candidates for this ultimate monist logic, but, you know, you don't have to, if you find all these tools useful, that doesn't philosophically commit you to logical pluralism.
Right.
Yes. Sorry. Oh, yes. To logical fallacies. Sorry, I just wanted to point out as well that there are also a huge. There's a huge camp of things that we call logical fallacies that resist formal treatment quite well. So something like a no true Scotsman fallacy. So, you know, I say something like, no true philosopher would fear death, and you point to me at a bunch of philosophers that did fear death. And I say, oh, well, you know, they're just not really philosophers. We tend to say, okay, there's something wrong with that. And people have used the no true Scotsman fallacy to label this. And I think, you know, we all agree that's dodgy in some way. And actually it's dodgy in a way that's quite difficult to treat formally because logic doesn't prescribe definition.
No, because you could construct an argument that says, like, if somebody is a real philosopher, then they don't fear death. This person does fear death. Therefore, they're not a real philosopher.
Exactly,
and that's valid.
You wouldn't want logic to dictate definitions either, because you would have a logic then that was not topic neutral at all. It's dictating an entire language.
The whole point about logic is that you can have the P's, and it's like algebra. Like you have P's, if P's and Q's and all this kind. And the idea is that like you can substitute in any sentences, and it will still work. If it's like, well, if P has this definition, then it works. But if P has this definition, it doesn't work. You haven't got a universal system of logic.
And this is where some fallacies or kind of other bits of faulty reasoning are more readily treated in a field called informal logic, which is, you know, which a lot of people just say isn't logic. And I kind of sympathize with that, but I like it as a term.
I think so too.
Informal logic is looking at arguments as they actually occur in the world and extending their scope slightly beyond formalism to sort of more broadly ask the question, what is a good argument? What is good logical reasoning, even in taking into account extra formal criteria? So an informal logician might look at that, the kind of no true Scotsman fallacy, and say something like, right, okay, well, we're not just considering formal constraints. What is a logical argument for? That is in a logical discussion for, or reasonable discussion for. So we kind of get out of our formal heads. It is for the communication of ideas under the assumption that the ideas with the greatest support will be accepted, the ideas with less support will be rejected, etc., etc., etc. And you can, you know, informal logicians and philosophers will define certain rules that dictate the kind of things that go on in a idealized, reasonable discussion. We can almost think of this as a language game, if you wanted. There are, one of them might be that you can't, if you can't dismiss an opponent's point without giving a formal argument as to why it's not true. That's a rule of discussion in a reasonable discussion, but it's not a rule of logic. It's not an axiom. And there's no kind of logician that's going to kind of go around your house and beat you up if you don't follow it. But you're departing from the conventions of a reasonable discussion.
Yeah.
Another one might be, you've got to ensure that your opponent and you are using similar terminology. Or you might say you've got to ensure that you and your opponent are making your points clear to your opponent in terms that they will understand. And you could say, well, the no true Scotsman fallacy, if you want to accept this as a rule of conversation, a reasonable conversation, you could say, well, the no true Scotsman fallacy is in contradiction to this. It's not that it's logically.
Yeah, I mean, you haven't
invalid.
committed a logical contradiction by going, "Well, they're not really philosophers." There's no logical contradiction, but it feels like we want to be able to incorporate the wrongness of doing something like that, and that's where you get these informal logical fallacies.
Yes, another one is like the Mott and Bailey fallacy. So,
in fact, I think the majority of logical fallacies people have heard of are probably informal logical fallacies.
Yes, because a lot of logical fallacies will depend on context. It
So
depends
what's the Mott and Bailey?
Mott and Bailey fallacy is where you have two versions of an argument, one of which is modest and very defensible, which is the Mott, and another which is more ambitious, but significantly harder to defend. So say I am I'm a particular kind of theist. I don't, I don't want to kind of rag on anyone here, but this is a kind of a type of argument that you might have encountered is where someone says something like, okay, there must be an origin of a per se causal chain. Therefore, we have a ground level metaphysical point, and we call that point God. And if one challenges them on any theistic matter, it's very tempting to retreat to that. And then the Bailey might be something like the God of the Bible is true, significantly more ambitious, significantly harder to defend.
Yeah.
And Aquinas has arguments as to why these. I'm not accusing Aquinas of this.
But it's sort of the idea is you put forward an argument like, the God of the Bible exists, and someone says, well, are you sure about that? And they start interrogating them, and that person starts retreating back towards, oh, well, I think there's a first cause of the universe.
Exactly.
And it's sort of like, okay, but you've just retreated into a much simpler, so you're now defending kind of a different, more like modest version of the argument. That's the Mott and Bailey fallacy. But again, you haven't, at least strictly speaking, you haven't done anything like illogical.
Yes, because you've switched. If you were to analyze that in terms of propositions, nothing is. You've not made any kind of invalid point.
And another helpful example might be like the ad hominem fallacy, right? If I say, like, Joe, like, I just think you're stupid, and therefore I don't agree with you. Someone will say, well, that's the ad hominem fallacy. So I haven't committed a logical fallacy there. I've just said, Joe is stupid, therefore he's wrong. Which
you can render that as a formal fallacy if you like, and there are a number of arguments whereby it's the line between a fallacious usage of something and a non-fallacious usage of something is surprisingly thin.
Yeah, so you could formalize it. You could say something like, premise 1, Joe thinks the sky is blue. Premise 2, Joe is stupid. Conclusion, therefore, the sky is not blue.
Yeah, exactly.
That's an invalid logic, and that would be a logical fallacy. But that would, as you say, like all genuine logical fallacies, kind of just collapse into the non sequitur. The non sequitur is a fallacy. The non sequitur fallacy is committed when a conclusion doesn't follow from the premises.
Yes, exactly. And all.
If it's raining outside, then I'll get wet. It is raining outside, therefore my raincoat is red. That's a non sequitur. The conclusion just doesn't follow from the premises. And so a logical fallacy, a formal logical fallacy, will involve some kind of problem with the structure, whereas an informal logical fallacy will be harder to pin down in logical language.
And you can say, and some things that people call logical fallacies are arguments where one of the premises is unsound on its face. So some ad hominem fallacies might be rendered like this. You say something like, this person is stupid. Premise 2, everything that stupid people say is false. Conclusion, anything this stupid person says is false. Yeah. And you say, well, that's, structurally fine.
It's a valid argument.
Soundness-wise, most people kind of go, well, premise 2, that's obviously not true.
Yeah.
So, you can
So
analyze.
that's the ad hominem fallacy, but you have to be careful to remember that I don't think we should call them logical fallacies when they're like, as you say, informal logical. They're just like fallacies of a different kind. They're unsound, but there's nothing wrong with the logical structure. So I think this is actually one of the problems is when you're having an online debate and someone says, oh, that's an ad hominem fallacy, or that's a Mott and Bailey, or that's a this, or that's no true Scotsman. They often throw those out as if they have the same force as proving to someone that their argument is literally logically invalid.
Yes,
which it's not. I mean, it's still bad to do that, and that might show that their argument is faulty, but it doesn't have the same, like, this is absolutely, like, demonstrably invalid in the way that a formal logical fallacy does.
And of course, in either case, you're just proving that an argument is fallacious isn't sufficient to show that the conclusion is false.
That's also important to specify, yeah.
A huge number of very, very bad arguments for true conclusions.
Yeah. So, like, the fallacy of composition is an important one. Like, you might say, like, so some people say, like, everything in the universe has a cause, therefore the universe has a cause. So that commits the fallacy of composition. It's like saying every brick in a wall is small, therefore the wall is small. That doesn't follow. But sometimes you can use that fallacious argument that where the conclusion doesn't follow from the premises, but the conclusion is true. All the bricks in a wall are red, therefore the wall is red. That is actually true, but it's still sort of committing this fallacy. But fallacies don't always mean the conclusion is false. It just means that the inference of that conclusion from those premises is, like, illegitimate.
Yes, and also, for the wall example, you could analyze that as having an implicit premise in it, right?
Yep.
Which is, say you wanted to add premise number 3, you could say that, well, a hidden premise in that argument is that redness is the kind of property that transfers from parts to wholes.
Yep.
And then, you can cash out the fallacy of composition, the other side, saying, well, smallness is the kind of property that transfers from parts to wholes. You can say, no, that's not true.
That's false, which is why that one's invalid and this one is valid.
So there is a fair amount of freedom in how you take natural language arguments and choose to treat them.
Yep.
Kind of using kind of propositional form and stuff like that. I think that oftentimes one, a criteria for how you might want to go about this. Oftentimes, it's kind of generally to go with, like, informativity, like how much does it tell you about the other person's argument? Is a pretty good metric for, in practice, how it's going to be most helpful to formalize that argument. So, one of the dangers of formalizing every ad hominem fallacy, for example, as simply this person's stupid, therefore what they say is wrong, is that although that gets to the representation that argument is invalid and therefore a bad argument. You might discover that your interlocutor, the hidden premises supporting your interlocutor's ad hominem fallacy might tell you something about their wider views or the other kind of moving parts of their philosophical framework, and that can be very handy.
Yeah, and it's important to note that, like, it kind of depends exactly what's being meant, because, like, there are times when the so-called ad hominem fallacy might kind of be appropriate, which is to say, like, if somebody says, I believe this proposition, and I say, well, why do you believe that? I believe the earth is flat. Well, why do you believe that? Well, because Mark told me. I'm like, well, Mark is a complete idiot and I wouldn't trust what he says.
Well, there you go.
You could go, well, that's the ad hominem fallacy. But maybe the argument could be formally cashed out as, like, if somebody is stupid, then what they say is less likely to be true.
Yes, that's
and so this is a statement that this person said, therefore this statement is less likely to be true.
Yeah, so if we were going to formalize
could still be fine.
Yeah, we'd say something like, if someone is stupid, then their statements are less likely to be true, which is, like, plausible. It's plausible in the sense that actually I don't quite know what we would mean by stupid if it didn't entail that. Mark is stupid, therefore the things that Mark says are less likely to be true, where, we're saying less likely than the average person, I suppose, would be something, kind of a way that we could extra specify that. And then you've got an argument that at the very least isn't obviously unsound on its face.
Well, I think that the context in which this particular problem comes up the most is the appeal to authority fallacy. So there's this fallacy that says that if you say, well, I believe this is true because this authoritative figure says so, or the appeal to popularity, I believe this is because loads of people believe it. Yeah, that's kind of a fallacy, sure, but there are some contexts in which it is actually sensible to trust authorities. Like I don't know, you might believe in climate change because of scientific consensus, even though I'm not a scientist and I have absolutely no idea how to interpret, CO2 data, but no idea what's going on there. Like, it still might be reasonable to believe in climate change if the popular consensus of authoritative figures say that. Somebody could say that's an appeal to authority, and in some contexts you kind of want to be like, yeah, it is, but that's kind of fine.
Well, all the idea of something being logically fallacious would mean here is that it doesn't guarantee the truth of the conclusion. So it does, as say, if you were to chunk that down into propositional form, you kind of have the flip side of the argument we just gave about this hypothetical Mark. I'm so sorry if anyone in the audience is called Mark. Here you'd say something like, okay, if something is first premise, if there's expert consensus on something, it is more likely to be true. Second premise, there's expert consensus on climate change or any other proposition you want to stick in there. Conclusion, therefore, that's more likely to be true. And so I think that's a very a nice way of breaking it down. Partly because it actually immediately exposes the fault lines of a debate that you would have with somebody who doesn't agree. Because most of the time, if somebody is questioning expert consensus, they normally are questioning that first premise. They're normally saying, no, I think that even when there is expert consensus on something, that doesn't make it more likely to be true. So again, you can kind of see how breaking things down into propositional form in this way can do a lot to clarify the contours of a debate, what the substantive disagreements between you and your interlocutor might be.
Yes. Everybody, learn logic. Where should they learn logic? What can you recommend that they read if someone's got no introduction to this?
Well, so the Open Logic Project is a website with free logic textbooks. I wish I was involved. I'm not. Then they're there. Download them for free. Very, very readable. To give you an idea of how readable and kind of useful they are. The For All X free logic textbook was literally the textbook for the first undergraduate Cambridge logic course. That was
when I did logic in first year at university, it was Volker Halbach's logic manual, which I thought was actually quite a good introduction. That's where I would point people to, but I've done a lot less reading on logic than you have. So that sounds like a really cool project. Go and check it out.
That's and there's ones on set theory, there's ones on category theory. I don't understand category theory at all. I wish I did, but I don't. There are ones on probability theory. It's a fantastic resource. Another one, if you're more mathematically minded, the book, I can't remember who it's by, it's called A Friendly Introduction to Mathematical Logic. And that will take you right the way from formalizing statements through propositional logic, predicate logic, and all the way through to Gödel's incompleteness theorem, which is a tricky old proof. So by the time you've got there, you're doing pretty well.
Cool. Well, there you have it, ladies and gentlemen, and good luck to you. Joe, thanks. This has been fun.
Yeah, thanks for having me.
I say that at the end of a lot of podcasts, like, it's been fun, and it always is. But I think that I like podcasts that are quite a lot of time sort of discuss all over the place, but it's nice to have a particular task. Intro to logic. What's it all about? I think we've covered most of the important bases, at least to give people a basic idea. Yes. Resources in the description. Hopefully they agree that we've done a relatively good job here, and thank you for the time.
Oh, thanks for having me.